So, good morning, everyone. Good morning. Nice. I like the spirit. I love it. I love it. Did you all sleep well? Yeah? How many people, for how many people is the first day today? You? You? Okay, I give you a quick summary of what happened yesterday. I was never late. I was absolutely not nervous, and I know exactly what I was doing. Cool. All right. All right. So we're going to have... two of our gold sponsors have a quick pitch. Then we're going to do a little bit of photographs of the room. And then we are going to have our first keynote. But for now, Osrat from Armo.
Hi, good morning. Okay, so my name is Ashrat Nir, and I am head of product marketing at Armo. So yeah, I have an engineer downstairs who can actually talk to you. But in general, I'll do the pitch. Armo's mission is to build an end-to-end Kubernetes security platform powered by open source. We cover all Kubernetes security issues without adding to engineering's burden. Our products enforce organizational security and compliance policies without slowing down the business. Armo solutions make security simple and frictionless for DevOps and is embraced by security and compliance officers. As you can tell from the picture, we're very self-aware about misconfigurations and other security vulnerabilities too. So I'd like to leave you with this thought. Armo platform enables you to identify security issues in your Kubernetes setup and provides assisted remediation too. So give it a spin. If you're interested in contributing upstream, feel free to check out the Kubescape project that just hit 8,000 stars on GitHub yesterday. So a round of applause for the Kubescape maintainers. And stop by our booth and say hello. Thank you.
That was fast. And now we have Jasper from Solo.io pitching about service mesh, I suppose. Give it up.
Good morning. Can you hear me? All right. Thank you. Well, I was actually supposed to prepare something to say, but I have not. But so I'll just, spit it out. I'm Jesper. I'm from Solo.io, and I am here today with two fantastic colleagues, Christian, who will be talking later about some very interesting stuff, and Alessandra, who's one of the organizers here. Does any of you know Solo? Isn't that just amazing? Do you actually also know what we do? No? But that is absolutely fair enough. I know something about you. You are all kind of Kubernetes knowledgeable, I guess. It's a fantastic platform to do all your microservices stuff. It's a cool thing. On top of that, you may even have a service mesh. Istio. Does any of you have Istio? Not yet, but I tell you, you will have Istio at a certain point in time, because that is the only way that you can actually manage your Kubernetes environment. And when shit really hits the fan and it gets too complicated, you need Glue Mesh, which is our platform. So, to prepare yourself for the future, go to our booth, get to hear about Solo and the Glue platform, and you may even win a drone, get a t-shirt, some stickers, or a water bottle. All right? Thank you.
We have, can Jasper make himself known to the guys here in blue, please, if he's around? Not Jasper, sorry, Gijs. Gijs, you are Jasper. Oh, there you go. Thanks. We are going to have a 3 minutes, nothing happening, and then we will move on with Jasper. Gijs. Gijs. Still. So I've been just told that I have to say a joke. I don't have any jokes. I am going to need some of our people upstairs here in the stage. I would love to make a photo of the room and of the team. And let's start with Pablo. Pablo, will you be joining me, please? Give it up for Pablo. All of these guys have done a tremendous work to make this happen. Jos, will you join us? Dajit, sorry. Ayo. Nice one. Marcel. These guys are tireless. Andrea, please, upstairs. Meg, I have shamelessly forgot to mention Meg yesterday. She is the man behind the dream. And the man with the dream, Alessandro. Nice. I would love to take a picture of all of us. Oh, there you go. So for those that are not Dutch, in the Netherlands. All right, Gijs is not ready yet, so now I really get to say the joke. Do you know the one of the Italian, the German, and the French walking in the bar? I shouldn't get there, should I?
All right.
All right, let's give it up for Gijs.
Well, good morning, everybody. I hope you can all hear me well. This morning, I would like to tell the story about how Picnic, who's been cloud native from the start, decided to go on-premise and ultimately also decided to go back again. So, let's go. First, a short introduction about myself, just to know who I am and how I was involved with all of this. My name is Gijs van der Voort. I work now for about 3 years with Picnic, where initially I started off as the founder of the Python platform team to launch Python as one of the key languages to be used within the company. But already quickly on, I got involved with the infrastructure team at Picnic and took up the role of product owner, which I've now been focusing for the last 2 years or so. I've been in the field a little bit longer, so this was not my first organization, and was primarily involved with the edtech industry up until then, where there was quite a bit of infrastructure involved with running real-time bidding platforms for advertisements. Not so cool. Now my mother finally knows what kind of work I'm doing, which before she had no clue of. So what does Picnic really do? Well, ultimately, we are a grocery delivery service. Back then, we were one of the first. Now, of course, there's many competitors on the market. And one of the things that we do differently than especially the flash delivery services that you see nowadays is that we position ourselves as a milkman 2.0. So the milkman in the Netherlands was this friendly face that would come at your door at a regular basis to deliver the groceries that you ordered in an earlier stage. And we want to replicate that kind of experience where it's friendly faces that you know that come on your doorstep, but now you do not have to order with him, but you can do it from the comfort of your mobile phone. And that's quite nice. In order to do this, the way that we differentiate ourselves from these flash delivery services is by actually fully controlling the supply chain. which allows us to deliver the groceries without delivery fees, which is quite nice. We can actually offer a wider variety of different products because we have a bigger sort of supply chain that has a bit more latency because we do not do, let's say, within the next 30 minutes deliveries, but therefore we can actually give you groceries for competitive prices compared to the regular grocery stores and with a big inventory of products that you can select from. So that's a bit of what we do. In order to facilitate, we control pretty much the entirety of the supply chain, except, of course, for the products that are still being produced somewhere and then from there being shipped to us. Infrastructure at Picnic was cloud native from the start. So everything is running in AWS, where we were running EKS at its core. We try to make use of most of what AWS is supplying. Our ingress controller, for example, is the AWS ALB. And we try to keep quite a consolidated stack of technologies. This allows us to specialize within those technologies and maximize sort of the benefits that we get out of this. And as we grow and new teams join the company or new people join the company, they can easily pick up the learnings that we did on all of those technologies for new products that they're starting to launch. And so with this consolidated stack that we manage via Terraform and Spacelift to orchestrate all of this, we enable teams with nicely prepackaged solutions so that they can focus on their deployments that are then running in Kubernetes, which we expect them to maintain. So infrastructure at Picnic is about the tooling around the deployments, and the development teams are actual DevOps teams that both do the building of the software but also the operations of the software. So what we do, let's say, on a daily basis, so a big part of the supply chain that we that make up our offering to our customers is actually taking the products that are shipped to us from the producers and turning it into something that we can actually deliver to our customers. I'm not sure how familiar you are with our proposition, but the small EPVs that we have, the electric vehicles to deliver the groceries, are quite iconic, and you see them everywhere across the Netherlands now. And those are fully tailored to the specific service that we supply. And turning all of those groceries, those big pallets of chunky stuff, turning it into something that we can actually comfortably deliver to somebody's doorsteps is a lot of work. You have to imagine that these different products, they all have different behavior of how to treat them. So, for example, we have frozen goods which need to be kept below 0. We have chilled products that need to be kept below 7 degrees. And of course, we have our regular products. But even then, you have stuff that can easily break. So a bag of chips, you cannot put it under a bottle of Coke in a tote that you're shipping out. And that adds a lot of complexity to this process, which we initially set out to do fully manually. So actually turning these kind of pallets into the things that we deliver, a lot of manual labor involved. And exactly that was something that we want to stop doing. This is exactly sort of the bottleneck that comes up in an organization like this. It's really hard to scale up. You have to imagine that the process that we've implemented is effectively a huge, massive supermarket, an industrial-sized one, that is fully tailored to optimize picking routes for people that walk through this. And that is great. We spend a lot of time on this, and we could maximize quite a bit, but it also has its limitations. Doing this work is, as you can imagine, it's labor-intensive, it's quite heavy, there's risk of things hitting each other, so it's also not fully safe. It's not the experience that we want for our employers. We want something better. And not only this for our employers, but also we just hit limits of what we can do on one physical location. So if we want to deliver more groceries with the same amount of people, we need to have something else in place. And for that, a couple of years ago, we launched the Welcome to the Future solution of Picnic to this whole problem, which was a fully automated fulfillment center. So that process where you have people walking around this whole, this big supermarket kind of environment has been replaced with a fully automated system comprised of about 14 kilometers of conveyor belt. Those conveyor belts, they all need to be controlled, and we need to control all of this such that we take the right products out of storage, we put them to the right people on the floor that actually take a product out of one storage tote and put them into another one in such a way that ultimately we have again the groceries prepared that we can ship out. And this operation is massive. This was the largest site that we launched back then. We now have some larger ones, but it was definitely the most complex thing that we tried to pull off. To control such an operation, there's a lot of software involved in actually making this happen. So in essence, there's 3 levels in which you need to operate such a warehouse. The first one is you need to be aware of what kind of orders are coming in and what kind of orders need to be fulfilled for what kind of moment in time, and track that those things are actually starting to happen. So we need to make sure that the products are actually in-house in order to fulfill those, etc. So that's sort of the high-level view. That is what we call warehouse management. Then there's a level of warehouse control, which is more about ensuring that the right products are put in the right bags, which are destined for the right people, such that such an order is actually fulfilled. And that is what we call warehouse control. And the last level, especially then in this kind of automated warehouse, you have something we call transport system. So this is actually the software that directly integrates with all of that physical infrastructure that is running on this site. So the conveyor belts, we have millions of scanners, we have actuators, junctions that we can put one direction or the other, a lot of physical stuff that needs to be maintained. Typically, if you would go in such a track, you can get these kind of solutions off the shelf. We have a vendor that is actually building all of these conveyor belts for us. But Picnic, from the start, has been pretty focused on building software themselves, which you normally would get off the shelf. This has been quite a successful method for Picnic. It allowed us to optimize a lot of processes in our supply chain. And we also believe that we should do the same for warehouse control in this case. Warehouse management we already did for our manual FCs. Warehouse control was something you would typically get off the shelf, but this, especially here, is the place where you can do a lot of optimization and improvements, which you would otherwise have to wait for a third-party vendor for you to implement. So with this kind of model, the question came to us as an infrastructure team, like how can we facilitate this? All of this software, where should we run this? So we started to think about the different types of, the way that we should want to do this. And effectively, we were able to identify 3 distinct types of workloads. The first one is the one that we all, I think, here love and enjoy. That's the stateless containerized deployments, your typical Kubernetes deployment that you can easily scale up and down. This is, especially in this case, the Picnic software, the things that we always build ourselves because that's what we do from the start. And then, of course, some of the open source solutions that we have around this to facilitate all of that. Then the second one is the stateful VM-based systems. I'll come back to why this is VM-based. But in essence, it's the data stores that we would normally get as a SaaS solution. We now somehow need to run this also close by because it needs to be on-premise. This would be Postgres, RabbitMQ, or it's our typical data store stack. And then the last one, which is definitely a pain for such an operation, especially if this kind of this automated warehouse is destined to support about a quarter or half of the primary market that we cater for. So operational quality is essential, and then having systems that we know are not highly available means that anything you do with such a deployment effectively means outages, and that's a huge risk for our entire operation. In addition, a couple of, let's say, operational aspects were identified that we needed to be able to achieve. So the operational hours are effectively 22/7, all days except for King's Day. Well, we need to have one celebration at least. Then there's the availability of 4 nines that we need to achieve because it's such a critical part of our entire catering to the Netherlands. And then we only have a small team to pull this off. This combined with sort of the key, let's say, aspect of this whole solution, like this was a massive important milestone for Picnic to prove our long-term, let's say, way of operating, was quite a critical project. In addition, one very unique peculiarity, I think, for such an operation is that an operation like this runs at a fixed clock rate. So where normally, of course, you have to deal with web traffic and it goes with your typical web sort of load kind of trend lines. Here we have a conveyor belt that connects everything together that runs at a fixed rate. It's a little bit less than a meter per second. It means that everything that happens here is sort of event-based, so we have scanners everywhere, as I mentioned. They detect that the toad is coming along, and maybe there's a junction after the scanner. You need to decide, is the toad going to go left or right, or straight or right? That kind of decision point is everywhere in this operation. It's many, 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 many places. And for any kind of junction point that is being hit by such a toad, it means that that event needs to go from the transport system to the warehouse control system. The warehouse control system actually needs to do some smart thinking to find the next step. then send back the information again. And all that needs to happen in a couple hundred of milliseconds, or even less than 100 milliseconds, before that toad already comes to the junction point, for example, that you want to put into a different direction. If you miss this kind of opportunities, these toads will go into a wrong direction, and those kind of, let's say, misdiverts, what we call it, are very costly to recover from, because as early phase, it was just physical people. They need to go there, pick up the toads, put them back on another conveyor belt, and now we have all kinds of software built to do for this for us, but it does add a lot of complexity on top of our already quite constrained processes that are running here. And that is something that is quite different than some of the other operations that you would typically cater for. So we set out to find a solution that we felt like was able to achieve all of these kind of requirements and all of these kind of types of workloads. We opted for a VMware-based stack that we externally manage, that we let external people manage, and it's fully running on-premise in this location. This specifically was decided with, you saw the team size, not so big. That allowed us, the Picnic infrastructure team, to focus on the actual catering of the workloads. So in this case, the Postgres clusters, RabbitMQ, the Picnic workloads around this, to make sure that that all works. We opted for running 2 identical rooms that were fully prepared to run the entire production workload, allowing us to continue operation even if there's a reason to shut down an entire room. You can imagine that if there's a power outage in that room, or you want to do some significant maintenance or refurbishment on the internals, we can actually do this without impacting operations, because we have that kind of capacity on site in another place. We actually had an issue quite early on where the cooling unit completely shut down in one of the rooms, and that allowed us to immediately shift all of the workloads to the other room and continue operation there, which is very handy in such a situation. And the VMware layer actually gives you the opportunity to transparently migrate workloads, VM-based workloads, from one location to the other. So on one side, it does it for you if actual physical hardware fails, so it detects it and it will start up the VM in another location where there's still capacity. But then also, it offers a solution they call live migration, so you can actually move running VMs that are actually part of critical operations. You can do it live, migrate it from one place to the other without impacting operation either. And that especially is a very nice feature to allow us to do all kinds of maintenance to the existing hardware that is there. And then lastly, vSphere comes with a solution they call fault tolerance, and I think this is a very interesting one. It allows you to run any VM-based workload in replication, effectively, that was never built to be highly available. In essence, what they do is they run the same VM twice, and then synchronize them fully, so on the network stack, on the operations that are executed in the CPU, and only when something goes wrong in one of the 2 instances will they divert traffic to the one that is still remaining. And especially for the workloads that I described that are not highly available, this was a very important feature for us to add on top of. And then, of course, we still want to do Kubernetes. Picnic, and especially the teams building the software to control all of this, they've grown up essentially in the company to use Kubernetes, so we want to still have the same offering. And in this case, we opted to run Tanzu TKGI. So this is the VMware offered solution for managing Kubernetes clusters, essentially sort of the EKS of VMware. We opted specifically for this because it gives you something that they call VMware validated design. So in essence, this is VMware that's going to tell you, sure, if you use all of these components stacked together, then we guarantee that that functions as it should. And that is a nice guarantee, because especially if something goes wrong, we can rely on VMware support to take this serious and to help us out to solve these kind of issues. Now, that's all good. And of course, while opting, there's a lot of choices that you have to make and decisions that you have to consider. And especially, I think, for the audience like you guys, there's a lot of options that might have come already up to mind. So one thing is, of course, you can run Kubernetes directly on hardware, or at least we can find a solution that allows us to just use Kubernetes directly on some physical infrastructure. We opted not to do this, mainly because the workloads that we've already identified, we needed to run those VM-based workloads that are not highly available. But we also felt that there's too much of a skill gap to also take responsibility for actually maintaining these kind of clusters on the master node level. we heavily rely on EKS, so we are actually users of Kubernetes and not the operators of actual clusters. At least that's how we see it, and therefore we felt it was too much of a risk to go into this direction. You can run, of course, virtual machine workloads within Kubernetes via KubeVirt, which actually is a really cool technology, and I think I would have loved to use it, was it not for such a critical site at that point in time. It supports live migration, which is nice, but it's behind the feature gate still, so effectively a beta feature, which is really a bit on the risky side. And of course, it didn't have that turn a non-HA workload into something highly available, which for us was back then especially quite a miss. We also considered to run Postgres and RabbitMQ in Kubernetes, because now we need to suddenly run VM-based workloads for this. Especially then, we were looking at Zalando's offering for this, which was quite new back in the time. Especially for Postgres, there was a lot of people that would still actively refrain you from using Kubernetes for running these kind of systems. So we also opted to play it safe and go to something that we at least know. If we go into these boxes, we can actually look at there's no abstractions around this, there's no Kubernetes operators or something else that is making it harder to debug. We can go into these boxes. We had people that knew a lot about Postgres, so that felt a lot safer. And the same goes for RabbitMQ. Of course, we have the operator that is supplied by the RabbitMQ team, but still, if something in that direction goes wrong, we didn't feel didn't feel enough prepared to tackle those kind of issues in such a capacity. And lastly, AWS Outpost. I think this one is something that, especially if you would redo this now, would be a very high contender. Back then, it was just not generally available for the Netherlands. We did have good lines, and there was some opportunities to try it out. We would be early adopters. And you would see this, for example, in the support for RDS. Back then, the multi-AZ or failover, at least functionality, was not there or not fully ready. And especially back then, it was massively more expensive than the solution that we opted for with vSphere. Now, I think it would be a very interesting candidate to explore. Now, with such a solution in place, you think, okay, well, we have all of the technology, we have all the tools, we feel that these are the right set of technologies, and we hope that with that similar kind of experience that we were looking for with hardware virtualization, all managed, a platform that is similar to EKS, is it as easy to operate? Well, honestly, it's just super complex. We ended up with a completely new tech stack that we had to operate and maintain. We were good in AWS. We have a lot of experience there. We built a lot of tooling, and we effectively had to duplicate all of this. We were hoping to be able to abstract away these different types of models of operation into modules of Terraform, in Ansible, etc. It just doesn't work. The details are too painful to abstract away, which meant we had to do a lot of things twice. For a lot of the technologies, we need to build a custom stack of observability, where otherwise you get these out of the box from AWS or for other providers. Now we needed to do our own observability stack for Postgres and for the proxies that come with Postgres, etc. Quite a lot of complexity, and then of course we do this for the first time. So yeah, you're gonna run into issues that have already been solved, that others have already been doing better, and that's just a painful operation. So the end result of this is that yes, we were able to pull it off, but we have a huge high operational load, and the reliability was definitely not what we were hoping for. Now, this was not something that was only hard on the infrastructure side. Running this operation was tricky for everybody. It was the most big project that we ever pulled off. And just getting it also on the physical level working, on the operational side, people around it, it was just super complex. So the corporate development teams were already looking into an alternative way to do this, and they opted for something they call a hybrid FC, effectively less complex in terms of automation, a lot easier to build, a lot faster to build, and better to pull off. For this project, we opted for another third-party vendor, which actually said, well, I'm pretty okay with you guys running everything from the cloud instead of doing it on-premise. It was something that the other vendor was absolutely against, and was the reason that drove us to on-premise in the first place. And so with that, we built this, we launched this, it went super smooth. It was like a fraction of the time that we needed to invest compared to the other location. And so the logical question was, yeah, can we just not do this also for the initial location, FCA? In order to confirm this, there's only one way to do this. You can't really simulate such a complex operation. You just need to do it live. There's no way to validate such a situation. So in essence, we identified, let's say, the key points where we would know in the end state, this is where traffic would go from the cloud to on-premise, and started to introduce artificial latency on small iterations, up until the point that the operations team would come screaming at us, complaining that things were breaking down, give them time again to recover, and then identify if it actually was us, because there's many things going wrong in such a location, and then reassess what we wanted to do. Now, we had to do this multiple times, I think 5 or 6 times, super painful for everybody involved. Also, the recovery takes a long time, a lot of effort. But ultimately, we did conclude, yes, we can. And that was amazing, because now we suddenly can think about going back. We can actually say, well, if we want to launch such a location again, we start doing it immediately from the cloud. And if we can get to the cloud for this location as well, we can just cut our operational workload massively. And that is, from a strategic point of view, and let's say conquering the rest of the European market, a super powerful proposition. But then you are in a place where you need to do a lift and shift back to on-premise. Of course, on its own, it's not an easy feat. I mean, it's not the largest scope. I think a much larger lift and shift operations have been conducted, but we're already launching new locations. There's a lot of stuff that my team is now involved with. Doing a lift and shift back is not so great. But AWS actually has a service that they offer that's called AWS MAP, the Migration Acceleration Program. And if you're large enough and your annual spend that you will end up with paying with them after this migration is large enough, they will pay you for doing this. They will make sure that there's resources they get from external parties to actually help you do this. And now we're in the process into preparing all of this, where we, as a team, we just validate that the things that they're going to do are sound, and we make sure that operation's fine. But we can sleep between 1 and 3. They'll do the operation, and they do it very well. And that for us is super, super important. So we're very happy with this. Now, if you look at what we sort of learned from this, I think for us specifically, and I think for such an audience as here, and some of you probably already know, but Kubernetes just does not abstract away the actual physical world. If you rely on, so if you do not have, if you use the ALB ingress controller, then of course going to a place where it's not there, it's going to be harder. So if you've opted in for all kinds of SaaS offered solutions that you hook into your Kubernetes cluster, then going to a different location will just not be the same. A lot of additional complexity comes with this. And even if you outsource the management of physical and virtual infrastructure, you still have to deal with physical reality. We had a power outage, or well, we had a power vendor that was not very reliable. So every so often, we had the diesel generators kicking in, up until the point that the gasoline was just depleted, and the whole site came crashing down. Like you need to learn this, I guess, in practice. Maybe there's people that do this better, but it's just stuff that you have to deal with. And like I said, the cooling equipment failing, etc. And then, working together with these different third-party providers that build such a complex operation for you. If you say that this is mission critical or this is so essential for your organization, they are going to account for this. They're going to add buffers. They're going to make sure there's never any risk in there. And I think it also prevented us from finding a solution that might be much better equipped or fitting to what we as a company are and how we want to operate. And so I think it's important that you always collaborate very closely, understand where these requirements are coming from, and what is driving them, and in what capacity do you want to trade, let's say, responsibilities over certain decisions, instead of just assuming that everybody just needs to do what they need to do. And I think that's a very powerful thing, especially in such a complex operation. And then the last one is an interesting one. So there's actually an ongoing discussion now from, I think, the guy who created Rails, who is now shifting a lot of their cloud infrastructure to on-premise, saying it's going to be saving millions and millions. In our case, it's going to be actually more cost-effective to run on AWS. I mentioned already the buffering, some of the deployment requirements that our third-party vendor was asking for. They wanted physical, they couldn't do virtual CPUs, physical nodes only, very high resource usage, and being able to scale up and down in the cloud would still allow us to better fit this kind of resources instead of buying very massive hardware that's hardly used. In addition, the discounts that you get, the reliability that you get, and all of the solution, the functionality that you get out of AWS is something that you otherwise need to invest in yourself. You can do this, but it just requires a different strategy. And so In our case, it's cheaper, and it also allows us, for example, we're now playing around with the Graviton instances that are available for running also in Kubernetes. We're experimenting with this and being able to also adopt this now for these kind of allocations as well. It's just something that we really love and want to see further developed. So that is also something that we massively enjoy of this. And that's it. That's my story of how we went to on-premise, how we felt it's not so fitting for us, and how we're now moving back to the cloud. If you are willing to help out or interested to help build the best milkman that is serving millions of families, then always feel free to join and reach out on join the Picnical tab. And I hope you learned something today. Thank you.
Can you hear me?
Nope.
Okay. Do you have any questions for Gijs?
Thanks. Yes, thanks, guys. Great presentation. What happens when the connectivity fails between AWS and the on-premise warehouse?
So if the internet connectivity fails, right? That's the question, yeah. So we spend a lot of time on this and opted now for a double line of internet connectivity. So these are not just, let's say, T-Mobile and KPN, but this is, I believe the term is called dark fiber. So we have a network team that's focused on this. So these are physical different lines that go into different directions, that connect to different connection points that end up in different parts of the general internet infrastructure. All of this to account for, let's say, any wire cut or any physical, let's say, issue with those lines. In addition, we use what they call AWS Direct Connect, so that also reduces the amount of hops that you go over actual public internet, instead relying on dedicated lines directly into the AWS infrastructure. Yeah.
Thank you for the presentation. One question about the PLCs, which are in general mostly a very classical piece of IT. How does this work together with the very modern infrastructure that you're running in AWS?
Yeah, so in our case, so the 3 levels of control, so the transport system that is in place is effectively the bridge for us between that. So they take into account, they support all of those low-level protocols that sort of they translate to that physical world. And we just purely rely on the events and information that they emit. So we asked our third-party provider of this, we are really good in RabbitMQ, so whatever happens and that we need to react on, you emit an event on RabbitMQ and we'll take it from there. So we really completely isolated out that kind of physical and classical kind of IT infrastructure so that we can focus on what we think can do best.
Any more questions? No? Thank you very much, guys.
Thank you.
Brilliant. So we are perfectly on time. We are going to have a little leg stretch, or you can just stay sit with us. And we are going to start again at 10. Thank you very much. Again, afternoon. Good morning. That tells you where I am. We are going to have a talk from Christian from Solo. But just before Christian, we are going to have our friends from Rabobank, gold sponsor, have a quick pitch. And Geert-Jan defined himself as an architect at Rabobank. But I prefer what he said. I'm a technonaut head. That's what he said.
Techie by heart, yes. Well, good morning. Yeah, you might be wondering what is Rabobank doing here at this event. And the case is we're already in our cloud journey for like 6 years. And we already moved 51% of our business applications to public cloud or to SaaS solutions. And the challenge now is for our more complex workloads. And we started also doing our, well, I'm responsible for our savings and investments IT. And for investments, we're migrating our investments back office, core system, interactions to the market, etc., to Kubernetes. Because for more complex workloads, we saw, we need something else than the other platform approaches we do. And we're here to share that story. So this afternoon, a quarter past 4, I think, Sherwin will present really our journey on using Kubernetes for such a complex environment, complex application. And in the workshop room, I will, during the break, also do a short presentation about a cloud strategy in general. So if you'd be interested, I'll be there, have a cup of coffee. But for now, enjoy the session here.
Thank you. I'm sure many people will be interested in Rabobank's adventures in the cloud. For now, we have Christian Fekete from Solo.io. Give it up for Christian, please. Sorry, we're having a little problem with this buzz sound. It's not in the room, it's in your ears. It's being worked out, and it will, sorry for the overloss.
All right, good morning, everyone. This presentation will be about eBPF. I'm not sure how many of you are already familiar with eBPF. Yes, if you could raise your hand, please. Oh, nearly everyone. Are there any eBPF experts in the audience, maybe? There are some lights coming in, but I cannot see any. Last time I gave this talk, that was at Cube Huddle in Edinburgh, at the end of last year, and there were lots of eBPF talk there. And that was almost an eBPF summit because there were multiple talks. But here it's, I didn't see that many. So hopefully this will be something interesting for you, especially if you are just starting out with eBPF or you want to find a new way to experiment with eBPF itself. So first, some introduction. My name is Christian Fekete. I'm a field engineer at Solo.io. You can find the contact information of me on this slide. The company itself, we are an application networking company founded not that long ago. We are based in Cambridge, Massachusetts in the US, but we have multiple locations. We are all working remotely around the globe. We are doing mostly application networking related stuff, but that's a quite extensive field. So we are nowadays covering multiple layers in the application networking stack, starting from the kernel and ending at the regular traditional application networking application layer, that is layer 7 in the OCI model. Our products are open core enterprise subscription model, but we also have a few open source, completely open source projects as well. For example, Bumblebee that I will talk about quite soon. We have many happy customers. We are well funded. We are also hiring. So if this is something interesting for you, please reach out. Oh, and come and say hi at our booth and enter to win a drone. So first, my background, because this presentation has a title of how I get to know and love eBPF itself. So it makes sense to include a little bit of background of me first. As you can see, I was mostly a systems infrastructure, DevOps, SRE, platform engineer all my professional life. I was mostly doing the same thing in all of my previous positions, but you can see the trend how the name of the position changed over the years. My main focus is and was observability most of the time, so I designed and operated observability solutions for video streaming clusters, hundreds of VMs in on-premise data centers across the globe. These were serving millions of users. I was an SRE at password manager company that's quite famous nowadays. Yeah, maybe you can guess the name. And I was also operating clusters running Kubernetes and Istio. eBPF is quite a hot topic nowadays, as you also know. It also has a steep learning curve. And fast forward to last April when I joined Solo.io, I got to get familiar with this technology. I was able to make some contribution to our Bumblebee project and to the BCC framework as well, which, as you will see, is basically the first generation of eBPF-based tools out there. I was also able to create a developing eBPF application workshop. If you go to Solo.io and choose the events page, you can find workshops that we frequently do, and there are some eBPF specific workshops there as well. So first, let's see what eBPF is. eBPF is basically a flexible, safe, and fast way to inject custom logic into the kernel. The origins are dating back to the days of TCP dump. If you are around for a long time, you might have already used TCP dump to troubleshoot networking issues. That was using originally BPF, which is predecessor of eBPF. There are multiple use cases regarding eBPF. These can be sorted into 4 main families. For example, security, tracing, profiling, networking, observability, monitoring. Security is quite trivial because eBPF, as you might already know, is based on kernel events. So you are able to track actual syscalls happening in your system. Tracing and profiling is also quite important because you can get a unified overview of your actual process running in the user space, and you can get some information about this process from the kernel space. There are multiple profiler tools currently that are quite popular. These are nowadays the more modern ones are based on eBPF as well, for example, Parka. Networking use case, you can do, for example, layer 4 load balancing and other similar things with eBPF. Again, we are at the kernel level, so this can be quite performant and safe to do so. So that's another great use case. For example, Cilium can come to mind if you are familiar with that open source project. And the last family is observability and monitoring, and this is that I will cover in this talk. This is also a quite nice area because eBPF can solve observability challenges that cannot really be solved otherwise. This diagram is probably my favorite eBPF diagram because it's quite simple, but still it's, I think, the best way to understand what eBPF is and how it works in your system. On the left-hand side, you can see the user program. On the right, you can see the kernel space program. When you have an eBPF program, you have to take into consideration both sides because the user space program is the one that the user will interact with. This will display the statistics, for example, if you are getting some statistics out of the kernel. And the kernel side logic is basically where your actual eBPF logic is. So first, it looks like that the user program is responsible for generating the BPF bytecode. This is just some lifecycle management for your actual BPF code, but this also has to be done by the user space program. Then after the BPF bytecode is generated, it will load into the kernel. And as I mentioned, eBPF is safe. there's a verifier on the kernel side, and you are only able to run custom logic into in your kernel if it passed the verifier. It's fixed. So after the verifier is passed, you have that BPF rectangle there. That's your actual BPF logic. BPF is basically event-based. So you can specify multiple events, kprobes, uprobes, trace points in your kernel. And when these points are being reached in the kernel, you can trigger your custom logic, which is the BPF rectangle there. The last piece on the kernel side are maps. Maps is a way to exchange data between kernel space and user space. So once you have your data that you are interested in the kernel, you have to populate your various BPF maps on the kernel side. And from these maps, you will be able to read the data from the user program. And this is basically how you, for example, visualize this data. OK, so now we know that what eBPF is, to some extent. We know that, but why it's important? As I mentioned, it's important because it can be a solution to impossible tasks and scaling issues. Scaling issues, I mentioned that when I was talking about the networking use case category. eBPF is quite performant. It's in the kernel. For example, you can do some really effective copy operations that way between your network interfaces. So if you are operating at a really large scale regarding networking, for example, you are a cloud provider, it might make sense to look into eBPF. It can be also a solution for other impossible tasks, for example, observability-related ones. If there are some SREs here, I guess you had some hard time to catch out-of-memory exceptions in Kubernetes clusters because there are a few error-prone ways to catch those. If you want to export those as Prometheus metrics, then you might have an even harder time because there are no real exporters. You have to either mount the Docker socket someplace and get data from there. The C-advisor doesn't really cover all of the use cases of out-of-memory exceptions, so it's quite hard to get it right. For example, this is a great example where eBPF can help. And it's important because there are multiple personas, for example, application developers, SREs, DevOps engineers, and network operators who could benefit from this. In this presentation, I will focus on the SRE DevOps engineer parts because back in the day, I was also one. OK, why eBPF is scary? Because some can think that it's scary because basically it's the kernel. And that just doesn't have a quite nice ring to it. Nowadays, everyone is spinning up new web applications, microservices in Kubernetes clusters. Everyone is parsing JSON. You might have a Kafka queue in the middle of your stack, but basically, most of the engineers nowadays are not quite used to do some low-level systems engineering work. So when they hear that eBPF is something related to kernel side, to kernel, it can be scary. eBPF can be also scary because of the lack of the documentation. I'm not saying that there's no documentation. There are some. It's getting better and better. But you have to either seek out arcane blog posts by various eBPF authors, or you have to check out the kernel mailing lists, and the user experience is not that great. Most of the people, again, are not really used to check out the kernel mailing list if you want to troubleshoot a bug in your JSON parser web application. eBPF can be also scary because people don't really know where they can start to get familiar with it. There are lots of emerging tools. There's a new eBPF-based tool every other week, so it can be quite daunting to find the right one where you can get familiar with this technology. And I mentioned it already, it's the kernel, and I think that this is the thing that can be the scariest of all. Let's take a look at the eBPF landscape. On the slide, you can see the application landscape of eBPF. This logo collection is from the end of last week when I last gave this presentation. I was thinking about updating it with the new logos, but it was also quite hard to get these on this slide, so I decided not to. There are a few new tools out there, but as you can see, it's a quite extensive landscape. So again, it can be quite hard where to start with getting familiar with this technology. To make it simpler, let's focus on observability. And for observability, we can follow the advice of Brandon Gregg. Some of you might have heard of him. He is a great contributor, one of the biggest contributors to the eBPF ecosystem. This quote means that you should not reinvent the wheel all the time. You should not start from scratch. You should not program your way through everything. If there are tools available, let's just use them, because people spend hard hours to get to the point where those tools are working properly, and we should really benefit from using those in the first place. On the slide, you can see the BCC, a screenshot of BCC. There are multiple, basically the multiple layers are here, and there are some BCC eBPF tools attached to all these layers. So for example, if you want to troubleshoot, let's say, system libraries, then for example, KillSnoop can be a good solution to get started finding performance issues or troubleshoot issues. Then there are multiple other programs targeting different areas. This is basically a GitHub repository, so you can go to github.com and find the BCC repository, and you should find all these traditional BCC tools in the tools folder. If you want to run these, you have to do it like this. First, you write a single Python program, and that single Python program will contain the user space program I was talking about. That's written in Python, and the kernel space program that's written in C. But how is that possible? How can two languages be in a single program? It's possible because the C program is basically a string. And yes, this is one of the reasons why eBPF can be hard to start with. You can see a screenshot here. This is actually the killer troubleshooting tool. You can see the BPF code written in C inside a Python program. This was the traditional way to get started with eBPF. Then, during execution, BCC will call Clang LLVM and perform a header lookup to know where the certain points in the kernel are. Clang LLVM and the kernel headers have to be present on the target machine where you would execute your program. Then you have to compile your code at runtime, but this can be quite problematic because let's say you are operating, let's say, VMs in production, and you don't like to underutilize these VMs. So let's say these VMs are consuming, I don't know, 70% of the available resources, for example, CPU or memory. And if you, let's say you want to troubleshoot something, so for example, try to catch out-of-memory sessions. So you go SSH into the machine, deploy the script. You have Clang LLVM there. That's quite huge. You have the kernel headers available, but you have to compile your program. And you have a virtual machine that is basically consuming the proper amount of resources. But if you compile your traditional BCC code on that production machine, the SRE teams will be at your door in a few seconds, because those machines can easily tip over because you were operating at the at the desired resource utilization, and now you are performing a very resource-heavy operation. So it might not be a good fit for production use cases. There is a better way to do this, and this is by following the BPF core methodology. Core means compile once, run everywhere. For this, you have to have the BTF type information available. This is usually done by having a VM linux.h header file available on your system. This will make sure that you can run this everywhere. You will still use Clang as a compiler and the libbpf user space loader linker library. And if you have all these things together, you are on the route to create portable and better, more modern eBPF programs. The kernel and the user space code in this case are both written in C, which is great. So no more Python, no more injecting code as a string. And you can even compile it in advance. So after that, you don't need to have Clang to be available on the target machine. You can just compile it in advance, ship to the target machine where you want to execute it, and as long as the requirements are met, you can easily run an eBPF code in a quite efficient manner on a production system. But we can do even better than this. It's also possible to focus only on the kernel space program. As you would imagine, the kernel space program is where the really exciting and interesting stuff is. The user space is basically just plumbing. You have to manage the life cycle of loading the code, then cleaning up, then visualizing the data. That's not something that's very interesting. So focusing on the kernel space program can be much more interesting. So back to the original question, where to start to learn eBPF? The answer can be, for example, with the Bumblebee project, which is an open source project by solo.io. You can go to bumblebee.io or find the repository under the Solo.io organization. Basically, it's fully open source. There are multiple examples there, so it's a great way to get started with eBPF. What Bumblebee is? Bumblebee can help you to build, run, and distribute eBPF programs as OCI-compatible images. And it can even expose these events as Prometheus-compatible metrics, which is quite nice because you most probably already have Prometheus, so it's quite trivial to hook it into Prometheus and visualize your data that way. And if you are talking about the observability use case, it's also quite trivial to use the de facto standards. It's working like taking the existing libbpf kernel space code and generating the user space code for you without even knowing what that user space code will be. And we also wanted to focus on the user experience and the developer experience. So with Bumblebee, you have a Docker-like experience, meaning you can use basically very similar commands that you would use with Docker. For example, you can do build, run, push, to push the images, to pull the images, to build the OCI images with your code, and that's basically a really nice way to distribute these programs as well. You can see a very short video of Bumblebee in action. You can see an example. It's a C file. That's the kernel space logic. That's all you need. After you have the file, you can do something like build and use the local file there. After that, the image is built. You can push it into local or remote registry. After it's pushed, you can just run it. And it even has a user interface like this if you don't want to expose the metrics and just for developing, local developing, you just want to see what the output will be. Basically, for this, it's quite nice because you can use the, if you go to the BCC repository, you can find the libbpf tools folder inside this repository. And there you find most of the time 2 files per tool. And these files are basically rewritten to use the core principle, which is quite nice. These are the more modern equivalent of the traditional tools. And you can take examples from this folder and port these into Bumblebee. For this, currently, you only have to take care of a single thing, and that is you have to have compatible map types with Bumblebee. Currently, only hash map and ring buffer is supported. So there are a few tools that are using perf buffer. That was a traditional map type. You have to port that to ring buffer first, but after that, you can basically just put it into Bumblebee, and your code will work, and you have Prometheus metrics with the exposed data. On this slide, you can see a few differences between per buffer and ring buffer. One of them is using buffers per CPU. The other one is using a share buffer. There are performance differences. The event ordering is much better. The developer experience is also much better. There's a reserve submit API to make sure that you can write better code. The requirements are to have a fairly new Linux version, but I think most of the cloud providers are already shipping Linux versions newer than this, so these are not really hard requirements. I would have a demo, but I will skip this. Please find me if you are interested in a live demo. I can do it at our booth or somewhere around here. I will just skip this to go to the finishing slides. You can see the roadmap for Bumblebee here. We are trying to keep up to date with libbpf. There's an active development going on with the libbpf tools. There's, for example, a new compat layer that can make it, that can abstract away the actual map type that you would use. So, for example, if you are running your code on an older Linux where only perf buffer, the older map type is supported, then it will fall back on that. If a newer one, for example, ring buffer is available, it will use that. So these are quite nice improvements, and we are aiming to keep Bumblebee updated to be able to use these changes. We are also working on tighter Kubernetes integration, for example, to get correlation with pod names easier. And there's an operator work already in progress, basically, that can enable you to have Bumblebee deployed into Kubernetes clusters as a daemon set. And that daemon set can load the OCI images into itself and expose the data as it goes along. Currently, it's already possible to use Bumblebee with Kubernetes clusters. For that, you just have to package it as a daemon set. The original CLI tool can be packaged as a daemon set, and it's working quite well. If you're interested in a demo, please find us at our booth, and I can show it to you. We also planning to add new map types. We also plan to have logging integration, so you can, for example, log all the events that you would want to expose, and you can ingest these logs into your logging platform. We don't currently support histogram metrics types for the events. We just only support gauges and counters, but histogram is something we are also working on, and we are all the time working on adding new libbpf examples to the Bumblebee repository. And you are also all welcomed to contribute to those examples. My key takeaways from learning eBPF with Bumblebee can be seen here. Basically, now that I know that eBPF is really a game changer, focusing on only the kernel space is fun. It's much better than doing all the plumbing with the user space code. Integration is key because, for example, for observability, it's really nice to have integration with Prometheus right away. And we are just getting started, and we would like all of you to benefit from the eBPF ecosystem. So feel free to take Bumblebee for a ride, and please reach out if you have further questions. You can join our Slack and come to our booth to enter to a drone. Thank you very much.
Beautiful. Thank you very much, Christian. Before you get off, I actually have a question that is not eBPF. Do you know when ambient mesh will be made production ready?
Excellent question. Ambient just got merged upstream last week, I think, or maybe this week. Oh no, I think it was last week. And I have to double check it, but I think the next Istio version, Istio 1.18, will include this profile. So you can already, it's basically, yeah, you can, if you go to the Istio repository, you can find the ambient specific part of the README. You can download the artifact there if you want to try it out. You can also check out the academy.io website where we have a virtual environment running. It's a free course. You can take ambient for a ride there as well. But I think the next Istio release will already include ambient as a profile, so that's also a quite nice way to experiment with it.
Thank you very much. Do we have any questions for Christian?
Hey, nice presentation.
No, thank you.
My question is, can we monitor from in the observability space of eBPF, can we only see L3, L4 level metrics, or we can also see L7 level metrics? And if it is L3, L4 only, then will it be my primary observability, or will it be my default level observability? If nothing can capture, then eBPF captures. I don't know if I make sense.
Yeah, that absolutely makes sense. eBPF can be used for lots of things, and it can also, it can even parse user space logic as well. And it can also, it's also possible to generate layer 7 metrics, basically. So it's definitely possible. You just have to think about the most efficient way to do things, and you also have to take maintainability into considerations. So if there are tools available that might not already use eBPF, but are solving your problem, then it might make sense to use that for that purpose. But for example, let's say if you take monitoring as an example, in the Prometheus ecosystem, node exporter is the de facto standard to monitor host that can solve a lot of problems that you might already have. But for example, out-of-memory exceptions is a program that it cannot. So it might make sense to use eBPF for that one. Or let's say you cannot use node exporter for some reason, and but you only need a subset of the features that that node exporter can provide. Then it's also possible to write some eBPF code with covering those features that you are interested in, so you can have a more lightweight and efficient, node exporter based on eBPF, if that's what you wish.
Any more questions?
Thank you for your presentation. I had a question. So you presented a lot of cases where you could use eBPF, but what would be the use case that you would where you would not recommend using eBPF?
Oh, excellent question. Let me think. For example, there might be some cases where security is taken quite seriously, and running eBPF might require advanced privileges. There are improvements happening on this area as well, so there's currently a capability that is aiming to provide the least necessary privileges that are needed to run eBPF code. So we are getting there, but there are still some security concerns maybe that might raise some security eyebrows if you want to run eBPF in those cases. Another example might be, I'm not sure, but the previous question about layer 7 metrics, that's basically solved with layer 7 components, for example, envoy proxies. If you're running a service mesh, you get observability out of box to cover all these metrics. This can be solved with eBPF to some extent, but for example, Envoy and the Istio sidecars are a great and well-adopted fit for this use case as well. I would mainly with eBPF, I would focus on really hard observability challenges, because I think this is the area where eBPF can shine. And if you have fine integration with the observability ecosystem, then again, it's a great fit to solve these challenges. Running little eBPF programs and exporting those as Prometheus metrics is quite lightweight and quite efficient. The code for these logics is basically just, I don't know, 10, 20 lines of C code, so it's also not too hard to maintain. So I would say that's the best use case for eBPF, in my opinion.
Thank you.
Any more? We have one more question. Well, I'll take it then. I have one question. Christian, no, one more. So I have had the chance to play around with eBPF and try out maybe 20 or 21 of the most common 25 syscalls. And I saw that Bumblebee makes things a little bit easier, preparing the framework for the type of program that I have to run. But still, I think it's a very steep learning curve and a very hard adoption for consumers of the tech. Does Solo plan to make it even easier than with Bumblebee?
Yes, so for example, our product is using eBPF to some extent under the hood. For example, to accelerate the service mesh. We are also generating metrics based on eBPF, and we are using some part of the open source Bumblebee code in our product to do that. But we open source Bumblebee for this exact reason, to make it all easier. And we are not, yes, as you mentioned, it's still not the best user experience and developer experience. That it's quite steep still. But for example, on the roadmap, you can see that we want to have, for example, better and tighter Kubernetes integration. And that's for example, one area where we still have some work to do. Operator is a great step in that direction. But being able to correlate to actual pod names can always make it easier, because without this, you still to do some user space plumbing on your own to get the actual data. So the answer is yes, we are still working on improving Bumblebee, and it's open source. So if you have any idea or feature request, feel free to file a GitHub issue or even contribute to the project. It's quite a small project still, and I think it's one of the easiest way to get started with eBPF. So we are happy to onboard you to the open source project if you are interested in that.
Thank you very much, Christian. I'm sure that everyone was very interested, and no one dared to say that they were eBPF experts. Thanks, Christian. Please give it up for Christian. We are going to have a little bit, 21 minutes break. We are going to start again in this room with GitOps methodologies and a boxing match at 11 o'clock.
hello, hello, hello.
1, 2, 3, 4.
Hello.
1, 2, 3, 4, 5.
Hello. Perfect.
4.
Hello.
Checking. Hello. More checks. Hello.
So your favorite Italian again? Good morning. We are going to have a special presentation today. It's more of a boxing match between Red Hat and SUSE than than a presentation. Well, I'm very happy to have Herman and Roberto here with us. It's a beautiful example of community work. Red Hat and SUSE are competitors. They go on same clients, on same behind same technologies and all these things, but still they are working together to improve our open source community, and that's extremely. And if that's not an example of community work, I don't know what it is. So please give it up for Herman and Roberto. Thank you.
Thank you.
So hello everyone, and welcome to another GitOps session in the Kubernetes Community Days Amsterdam 2023. I'm Roberto Caradela, and I'm EMEA Cloud Services Black Belt, working for Red Hat.
And this is Herman Montalvo Yevenes. I'm a technical marketing manager at SUSE.
So today we will explain the different patterns for the different GitOps deployments and to manage cloud-native applications. So imagine that you are working in a platform engineer or a DevOps team that needs to manage hundreds of different microservices, and you recently adopt the different GitOps methodology. But you wanted to know also how to implement these different patterns that you have. So we will describe the different patterns that you can use daily basis as well, and we can introduce the different GitOps tools and projects to managing the different environments and also to managing the GitOps deployments and applications. So let's start with the GitOps tools and projects.
So in terms of the tools and projects, we're going to review first some of the projects that we're going to see. Can you go up, please? Okay, so the first thing, so we are not going to invest so much time in this because we are assuming that we are all familiar with the GitOps paradigm. So some of the principles, the system is described declaratively. It's a new good paradigm that we are going to see for deploying the applications, as even deploying or changing the infrastructure. The decided state is versioned on Git. The different states, the current states is what we get from the clusters, and the decided state is what we want to get. All the approved changes can be applied automatically. There's two major models. There are pull and push models, and both of them will be applied directly as long as we have the changes in the Git repository. And also a controller exists in case of any drift is detected between the current state and the decided state, what is declared into the repository, and what is reported from the cluster itself. So one of the major tools that we are going to use is the Argo CD. We are all familiar with Argo CD, I hope so. It is a cluster and application configuration versioned in Git. It automatically syncs configuration from Git to the clusters. In case of any drift detections, you can visualize and correct it depending on how you configure that. It provides granular control over sync order for complex rollouts. It can roll back and roll forward to any Git commit. So the Git will be a milestone, a point on time about what our infrastructure was at certain point of time. And the manifold templating support, which is going to be the major point of this talk. This is going to be a lot talking about the templating. So this is focuses on the customized, but we'll be covering also Helm. It can also provide some visual insights about the situation we have into the infrastructure. So when it comes to manage a large number of devices of infrastructure, one of the major tools that is really useful is Fleet. Fleet is an open source GitOps solution designed specifically to manage large number of devices or infrastructure. This is really good because in terms of the edge architecture, for example, where infrastructure needs to be increased or adding or removing with flexibility in terms of having a manufacturer or whatever, it is really good because Fleet can group in different devices, and the configurations can be leveraged just applying a certain numbers or for a specific environments or devices. So,
let's start with some fun with GitHub patterns with Argo CD. You have also this QR and also this URL, and if you just scan it, you can go to one open source repo, and you can reproduce every single demo that you have in here. So we like risks, and for that reason we are doing live demos with a hotspot, so yeah, it will be fun. And we have also our Argo CD instance in here, and in this different QR we have different demos, so we can start defining the different demos that we have. The first demo that we want, and the first pattern, is that the Argo CD applications, projects, and the different settings can be defined as another Kubernetes object. So you have here an Argo CD application that is just another Kubernetes manifest. And you can apply this application defining the different source, and you can define the different repositories, paths, or also environments, and the destination that could be the exact same cluster or could be other remotes that we will see in another pattern as well. And the most important part is the sync policy that defines, for example, when Argo CD detects the drifts between the desired state of the manifest and also the live state of the cluster, will define if there is syncing manually or automatically given these drifts. So the pattern 0 is yet another Kubernetes object, and you can define the Argo CD applications.
So let's jump into the first pattern, customize to the rescue. Customize traverse a Kubernetes manifest, adding or changing the configuration as needed. This is going to be the core of the course, along with the Argo CD. Some of the principles we have with the customize. Customize consists in a base file, some of the base files with the customization.yaml file itself, which is declaring what is going to be the files that will be changed, or some of the specifications that we're going to add. Depending on which environments we want to create, based on the base, we will be able to create some overlays. In this case, for this example, we have two, the development one and the production one. Each of them has different CPU counts, replica counts, and other customization that we want to add. The major point of that is we don't want to duplicate the files depending on the environments, because this is okay for one application. Let's try to imagine this with thousands and thousands of applications. It's almost impossible. So this is really good for templating things, because if you are templating with customize, you remove that need of duplicating things. So let's jump to see that into the demo. So we go to the repository, the first one, the first pattern, and just copy and paste the files that we have prepared for you. If we go to the dashboard, we'll be able to see the application is deployed, and we can see the different objects available. If you go to the details, you can see the repo URL, so it's pointing to the Git repository where you have all the customization files, and with a specific path. If you go there, you will be able to see the customization file itself, which is pointing, if you go into the customization, thank you, buddy, it's now targeting using some of the resources available and the patch strategy that we want to change. In this case, for example, we want to targeting this specific deployment. This deployment we have here with the name of BGDK will be changing these values here. So we want to change the first item into the first array, and we want to change that value to yellow. Kustomize will read that and will apply the changes to the application deployed in Argo CD. So if you go back here and see the application's details, go down into the manifest. I hope everyone can see that. You see the first item in the value, it's the name of color, thank you, and the value of yellow. So in this way, you can change that. So imagine this as development environment. You can push that to production, and you can change that to the desired value that you want to.
All right, then. First, demo live. So what if you wanted to control the ordering of the different GitOps? Because GitOps, it's syncing every single Kubernetes manifest. But what if you need to first deploy your database? insert some data into the database and therefore deploy your front end. How you can control the order within the GitOps deployment. Introducing sing waves and hooks. A sing wave is a way to order how the Argo CD applies to the different manifests stored in Git. And all of the manifests, all of the Kubernetes manifests have this annotation with this sing wave and also one number that defines the grouping of the different applications. So you can group and you can define first is the database, and then you can apply different things like the front end, implying also and defining other things. And a very handy also tool is hooks that could be and can run before, during, and after a sync operation. So in this specific demo, we will insert some information usually in the API when everything is ready. But you can send messages in Slack, send, if everything, for example, works well, you can send one Slack message. If everything was wrong, you can send a PagerDuty, for example. You can control the different stages on that. So in this demo, we will control the order, and we will first deploy the database. We insert data, we will deploy the front end, and we'll make an HTTP call just with a single kubectl, hopefully. Let's see. So if we go to the second pattern, in this second pattern, we have the to-do application, we copy-paste it, we go to the pattern, T, and we deploy it. Just we go to this, we show it because it's pretty quickly, and as you can see, this is not a big bang. It's having order. It's first deploying the application of the Postgres and applying also different things like the front end as well, and it's doing everything with the different order. So it's not applying every single object that detects. It's maintaining the proper order, defining, for example, this. How you can control it. Remember that we applied sing waves, and we have a sing wave with 0 that it's applying the first time, and afterwards, when it's ready, when it's deployed and synced properly, we have also the sing wave 2, defining different things that we can control, and controlling the order within the different GitOps deployments. So you can have the power of controlling and orchestrating your different Kubernetes manifests.
So what a good way to orchestrate things, right? So let's go to see the third pattern here, the GitOps orders awaken. We already see what happens when we have to define a single application. We go to the Argo CD, we define what we want to the Git repository, but what happens when we need to scale this up to 1,000 different related applications? We cannot have a single definition for each of them, because managing that or sending that to the operations teams will make them mad. It's possible it's going to reduce or increase the retention policy of the employees. So the question here actually arises, what about deploying multiple related applications at once? So we don't want to end the day like this guy with just handling the different files or just trying to, okay, where I would put the configuration for that Argo CD file. This is intended for a specific cluster, this is for another one. This is almost impossible. No one wants to deal with that. If you have been in the industry for more time, you will probably know how that feels. So then the Argo CD app of apps pattern is going to rise to be the solution here. It allows us to define a root Argo CD application that will itself define others Argo CD application belonging to the same one. The root apps, the Argo CD root application points to a folder in Git IT where you have other files, where you are defining the Argo CD plans or the components that belongs to each application. That doesn't mean you don't need to define the rest of the application, but Argo CD, when it comes to deploy, you deploy the root application and it will be orchestrating the rest of the components. So we're going to see that into a demo again. So if we go to the repository, pointing to the demo, pattern 3, just as before, we're applying the the deploy to the Argo CD. There we are. Pattern 3, and we just applying what we get from the repository. We go back to the dashboard and we filter in with, just to remove the rest of the application that does not belong to this app. So as you can see here, we have a bunch of different Argo CD applications, but we just deployed the root Argo CD application. It's the one that you see into the top left corner. So if we go to the root application, we can see that is the root application, the root Argo CD application. And the application you see on the right, the Argo CD application you see on the right, belongs to the same root one. So if you see on the details, you can see the path, and the path is pointing to the different components. If you go there, it is pointing to the repository where you can see the rest of the definitions, the YAML definition of the rest of the application belonging to the same one. But you don't deploy these apps. You deploy the root Argo CD applications. So you back there and you see some of the details that you can see on the application. Let's trust on the Wi-Fi. Thanks God. So you can see here the Argo CD application. This is one of the child applications belonging to the same root or parent application. As you can see, it's an application as always, where you can see some of the repo URL, so you can see the details, and everything is working as expected, but you just deployed the root, the Argo CD application. That is the app of apps.
All right, then. So I have a question. Do I need to define each Argo CD application in this pattern? Is there any way better to manage our application at scale? Because we saw just a bunch of applications, but what if you need to manage hundreds of different microservices, and you need to deploy it, and you need to also orchestrate, for example, development, staging, or production applications? So we introduce Argo CD application sets. With these application sets that is specific for Argo CD, you can target multiple Kubernetes clusters. And also you can, with a single manifest, Kubernetes manifest that we saw, you can deploy multiple applications from one to multiple Git repositories, improving this support of the monorepos. So we can have just one repo, one Git repo, and within you can define, for example, one folder, structuring your different development, staging, and production objects and Kubernetes manifest as well. And within this multi-tenant clustering, you can improve the ability of individual cluster tenants to deploy different applications controlling your different environments that you wanted to target as well. Using that, we are using the generators. So we have 4 types of generators, and we will focus in this demo in 2. That is the Git generator that will point to one specific Git repository with this folder, and also you can use other generators in this demo. So we will demonstrate managing this GitHub application at scale. We prepared the 4th demo, and so far so good, trusting the hotspot and living in the edge. And we will deploy dev, staging, and production environments with a single Argo CD application set. So if we go again to the applications, we remove the filter, we saw a lot of different things, and we just go to the pattern 4. In this pattern 4, we will apply these Argo CD application sets, and with this application set, we see that if we filter with different projects that we have the different staging projects. So these staging projects are the different Argo CD application sets that we define it. These application sets are pointing out to one specific generator, and we use the Git generator. So you can define the different directories, and you can put whatever you want inside that will recognize automatically, defining inside of this. If you put, for example, more applications, will pop up here and will appear without the need of defining every single object, every single Kubernetes manifest, just popping up right now. And if we add, for example, another folder, will sync and will have. So we are structuring we are defining everything that is here. So we have this also for prod, and everything is right. So far so good. And we have another type of generation. We focus just in one cluster, but what if you want to deploy it in multiple clusters? Argo CD can also define with using the cluster generator that automatically generates these cluster parameters. If you have your credentials, you can target with one single Argo CD instance multiple different Kubernetes cluster, and you can have, for example, inside of your Argo CD different Kubernetes clusters managed that could be within or distributed across different environments. And therefore, you can have also this generator with these clusters, and you can use this in order to deploy your different environments, your different development environments, staging that are you defining in one single repo, and using these generators pointing and deploying with one click your entire infrastructure, your entire environment across all of these Kubernetes clusters. So you have a lot of power for using that generator as well.
And the last button we're going to cover today, not to mess up with the time, it's the promotion between the GitOps environment. So this is what we want to get. We want to have the source code, we want to build into the QA, then promote between different environments. So how do we use that so far? We have different branches pointing to different environments, the production environment, the staging, and the QA. And when we want to move some changes, we just promoting the changes, just merging one branch to another, or using any Git strategy base. This is not what we want to do during this demo. So we need to move out because it will require to have multiple branches, multiple files, and it's going to be complex to handle when it comes to edge architectures. So if you see at the files hierarchy, we have dependencies, we have a bunch of different base files, and then we have the envs and the variants. And we have some specific extra settings that we are adding for each of the environments. If we go to the customize, we are going to see the base files. Some of the results are only pointing to the base files with the different components, which is belonging to the variants, in this case for the Europe, and the patches strategic merge that we are going to use for both file deployments and the version, because these two are relevant to promoting the content from one to another. So, please. Thank you. Then we have these different steps. This is a very graphical, visual way to visualize what happened when we try to move that from one. So into the first step, we have the EU variant. This is the one that we want to move between the different environments, and we are applying the different extra settings that we are going to add, depending of the stage we have. So, two different scenarios. How are we going to promote application version from dev to a staging environment in the US? So we are not going to move that from the variants. Just copying the files into the repository. We are copying the files version.yaml from the dev GPU into the staging US. In the second scenario, we're going to do the same, but from the stage to the production. So we are going to move out. And if we see the div GPU version on the dev side, we are going to we are using, or we are testing the tag image 2.0. Once we have copied that, we can see the version on the production is still the one, because the changes that we are validated into the previous environment will be pushed into the next one, into the next environment, it will be promoted into the other environment. So everything that is validated in the previous environment will be pushed to the production or to other environments. So you don't lose the control, even if you are using this scenario. So, time for the Q&A.
So far, so good. Any questions so far? Yeah, sir. Perfect.
Much better, yeah.
Yeah, much appreciated.
So, if you have a new version of your application, for instance, and you would deploy it and then find out that stuff is breaking, would it just be reverting the version to a lower version and then deploy that up to staging and then to production, for example?
This is a way to go, yeah. You have also the rollback. So you can roll back to any specific commit because within every single Argo CD application, you have also the history and rollback. And it's defined in Git. That's the proper way to go. And if you are messing up with different branches, for that reason, we want to avoid it because we suffered that in the past. And for that specifically, we wanted to just go in with a better way in order to just copy one single file pointing out, and you can just go and roll back, going to one specific commit, avoiding pain, more in production and these calls into AM in the morning. So SREs, yeah. Yes?
Hi. How do you manage the control around deploying to production? So it's obviously a code review.
Okay.
How do you do that? How do you make sure that nothing gets deployed that should not be deployed?
That's a very interesting question because you need to, for example, define the promotions, and you can also use this P request in order to at least pull requests. So we did just copying it, but you can also demonstrate it, and you can put pull request and several reviewers in order to not mess up with different things. So is it just a demo? Don't do it in production. So just put a pull request, some reviewers, some linting, and you are good to go. And you have also the rollback, so you can always rolling back to one specific version that you know that controls and you know that works.
Just remember that rolling back, it's also a feature available in Argo CD. So if you want to roll back, a commit is just a point in time for my application. So if you want to roll back, you can always go back on the commit, on the Git, or you can using or fixing something into the Argo CD just to make sure that you have the right version of the application running into the previous stage.
All right then. Right. We have questions.
Hi.
Hello.
So in the pattern 3 that you explained about the apps of apps.
Okay.
So let's say that you roll out a new version of your app and you have tested that in QA environment and that it works, but for some reason when you ship to production, you have a bug. So is there a way that I can detect that before going to prod and not doing rollback, but just testing it before just switching the traffic, or just?
Yeah, there is a bunch of different products that you can implement as well. And you can use, for example, Argo CD image updater in order to lint everything, prepare, deploy it in one scenario, and you can use also application sets. This is the next generation of apps. And you can define, for example, first the development and staging, targeting for one specific area and scenario. And therefore, you can then you can be and have this insurance promoted to GitOps using pull requests or whatever that you are implementing. So it's focusing first in these scenarios in development and in staging in one cluster, for example, and then applying this in production that you know and you have the insurance that works. Thank you. My pleasure.
Hi, I'm here. I have a question.
Hello.
So usually in an environment, we try to create artifacts through pipelines.
Okay.
The artifacts are usually stored in a repository. So I'm curious, how do you make the connection between a new artifact and your automated deployment? So if you have version 1 and you create a new artifact version 2, how do you want this process to be automated all the way into your GitOps repository without automating the auto commit?
Yeah, it's who controls the automation, isn't it? Yeah, it's a chicken and egg. So it's not easy. We try to simplify that, and we try to do it at least not doing the big bang. So if you see here, and it's messing with me, the Wi-Fi, okay, the different dev environments, you can define as well the different directories that you can. But you can narrow as well. You can deploy just a single specific application and test it. And therefore, you can increase this automation. It's not a big bang. It's just trying to make the things that works first, keep it a bit simple first, and then you can automate a little bit more. This is like patterns that we suffered. So if we are starting, this application set can save you a lot of time, but you need to take care with the automation as well. All right then. This one, because we don't want to eat. I mean, we are in time. We're from Spain.
Still so far, so far. Let's see how many questions we have.
I have a question about the same application set. This one is top-down. The top-down repository describes what children you have. Can you also have it in a decoupled way that a child says, I want to belong to this parent, and the other way around?
Yeah, and that's exactly that you can do with these matrix generators. You have different generators that you can deploy. So you have list generators that you can apply that specific pattern, and you can define this specific application that you want instead of doing this big bang, narrowing and doing that. That's the best thing around generators, that you have this flexibility in order to scale. And you have, for example, this cluster generator. And you can apply both. So you have this mix and match using the matrix generator that combines the different generators. So you can target, for example, development and the staging for one specific cluster, and use also this Git generator in order to deploy just single app or a multiple apps.
The generators will actually allow most of the definitions to be flexible, because independent of how you want to deploy your application or what is the strategy that you want to apply to the environment, you will be able to see how many generators that you need to use. Maybe you have just a single repository, maybe you have more than one cluster that you want to add, and maybe that's not applicable for most of the clusters. So you can add that kind of flexibility, specifically for Edge.
All right, then.
Yeah, one more.
One more.
Yeah. How do you handle secrets? Because there are problems around secrets storing in the GitOps world, and there are ways you encrypt and decrypt secrets.
With still secrets.
How do you handle in production?
With carefully. Carefully. I mean, yeah, carefully. I suffered in the past.
Usually using that there is some vault solution that is intended specifically to use that. For example, the seal secrets or
you can use seal secrets, and you can define it also inside with Lua, and try to sync, because this is like changing, and you need to be and tell Argo City that you are using these seal secrets that you can define in Lua as well. So there are some bunch of different strategies, but this could be like another talk and could be fun.
Probably.
So, so far so good. Thanks for listening, and yeah, live demos. So we are living in the edge. Thanks for attending.
Thank you so much.
Thank you very much, guys. Beautiful, beautiful presentation and example of collaboration. I loved it. I loved it.
Thank you.
Thank you.
Thank you very much.
People, yes, please go on and have a stretch. We are going to restart at 11:45 sharp with Service Mesh and Raymond from Cilium. Here we are again. Good morning. I think that the slide is misleading. There can be a mesh without a mess. But I'm sure Raymond de Jong from Cilium is going to show us, is going to prove me wrong. Raymond?
Thank you.
Give it up for him, please.
Thank you. Thank
Good
you.
luck.
Thank you. Good morning, everyone. My name is Raymond de Jong. I'm Dutch, obviously of my name. I work for Isovalent. Isovalent is the company who originated Cilium. How many of you know Cilium? Good. How many of you know what eBPF is, or eBPF in general? Cool, good. At Isovalent, I'm field CTO. I'm here happy to present about Cilium service mesh without the mesh, and I hope I can explain why that is. So first of all, I want to start for the people who don't know so much about eBPF and Cilium, what these are. After which, I'm going to talk how service mesh has evolved. And then look at a few features Cilium service mesh is offering today. And hopefully I have time for a small demo so you can see it in action. So eBPF, what is eBPF? eBPF stands for Extended Berkeley Packet Filter. That doesn't mean anything. It doesn't mean a lot. But how we use it is eBPF makes the kernel programmable in a dynamic way. We like to say what JavaScript is to your browser, eBPF is to the kernel. And what that means is that based on kernel events, we can do a number of things with that. So today we're focusing obviously on service mesh, so we're looking at a lot of networking capabilities. That means that, for example, when a process opens a socket, or when a network device sends a packet, or you see TCP retransmissions, those are kernel events where basically we hook eBPF programs to, and that allows us to get rich visibility and access to data to provide service mesh capabilities using Cilium. Also on the runtime side, we can also use eBPF to secure workloads and to be able to see, for example, file access, processes being executed, and secure and enforce there. Cilium uses eBPF to basically provide advanced networking capabilities. Today we're looking mostly at distributed applications where service mesh is at play, but you can also use Cilium standalone for high-performance load balancing, for example. Using eBPF, we can accelerate the data path using, for example, XDP. So Cilium is a broad solution for networking, observability, and security. This is the 30,000 feet view of what Cilium is able to deliver today. At the base, Cilium has a lot of networking features. Think about plain network policy support, Cilium network policy support. We can do encryption in transit using IPsec and WireGuard. We can provide load balancing east-west with a queue proxy replacement using eBPF. So we're replacing legacy IP tables, instead using eBPF maps, which is a lot faster, and meaning that every endpoint's IP is an atomic change instead of a linear list to be replaced in IP tables. Also multi-cluster capabilities, where you can mesh multiple clusters together, getting one unified data plane using Cilium. And finally, we also have things like egress gateway, BGP, overlay networking on the networking side. On top of that, we have an observability layer with Hubble that allows us to get this visibility at layer 3, layer 4, layer 7 to see what's actually going on. So we can see, using Hubble, using the UI, or using metrics, what service connects to what service, what are return codes, what is the duration of a request, is there latency in TCP, and so forth. On top of that is right now Cilium Service Mesh with Gateway API, Ingress, where we can support traffic management, and are also supporting Gateway API as such. And on the right side, we have Tetragon, which is our runtime solution, which is a session on its own. I won't talk a lot about that today. And Cilium can run on any cloud. It can run on-prem, can run on OpenShift. GKE Entos uses Cilium under the hood. Azure is currently adopting Cilium as the default data plane for AKS clusters. EKS Anywhere uses Cilium by default, and we're hoping that AWS is also switching in the future to use Cilium by default as well for EKS clusters. And it doesn't matter if it's on-prem or in cloud or both, and you can connect them together using multi-cluster capabilities. So today we're talking about service mesh. So where did service mesh came from? When looking at distributed applications, we want to see how they perform. So we need observability. We want to see how long a duration is taking. We want to see the return codes. We want to effectively troubleshoot it. We also want to secure it, either in transit, and we also want to do authentication. Perhaps we want to use MTLS to authenticate services talking to each other. We also want to do layer 7 traffic management, perhaps. We want to do path redirection or TLS decryption and such. And finally, we want resilience. We want to have availability across clusters, even across clouds if possible. So where service mesh obviously started was with binaries, right? Applications were having code to provide that kind of capabilities. At scale, that doesn't work. It's hard to maintain. You need to maintain all those binaries and libraries yourself. And therefore, we moved to a service mesh with a sidecar proxy model where all those capabilities were moved to the sidecar proxy instead, making sure that the application itself doesn't have to maintain all these libraries and making the development of that application easier. Obviously, the sidecar proxy has capabilities on layer 4 and layer 7 load balancing, but it also has a few downsides, as you may have known. So we're moving from a shared model to a sidecar model, and with Cilium, we're moving to a kernel model, meaning that we want to bring all these service mesh capabilities as close to the kernel as we can using eBPF. So today, the only thing which is not yet there is layer 7, mostly. We already, for a few years already, support the layer 2, layer 3, layer 4 capabilities in kernel using Cilium, using eBPF. For example, the east-west load balancing I just mentioned, using our kube proxy replacement, that's done through eBPF instead of IP tables. So layer 7, and there was also a question this morning, eBPF has limitations, right? And that's for good reason. It runs in kernel, right? So you have to have constraints and limitations of what you are allowed to do. And today, for example, something like HTTP path redirection or TLS decryption as such costs too much of code and processing to do in eBPF today. But it might happen in the future, but that's the reason why layer 7 is not yet there. Although Cilium already has all these layer 7 capabilities, we already see, for example, using network policies, we can enforce traffic on the API layer. We can see HTTP calls, methods, return codes. We can load balance and route gRPC. We can observe traffic using Grafana and Hubble UI. So Cilium already has these capabilities, and we're extending these capabilities using service mesh. So how does Cilium service mesh then look like? For starters, if you run Cilium as a CNI, Cilium runs as a daemon set, meaning that the Cilium agent runs on each node. And what we're doing here is that we use Envoy embedded in that agent on that node for proxy-like capabilities and enforcement and observability like layer 7 to be able to enforce, for example, HTTP requests. When Cilium is installed, and depending on the configuration you set, Cilium makes sure that the right eBPF programs are mounted on the nodes and are being able to execute it when you need them. So when you enable metrics, that happens under the hood. You don't need to be an eBPF expert to actually run Cilium. eBPF does its magic under the hood. So what happens with service mesh? So as soon as you trigger or enable a service mesh capability, that means that on the node for that given namespace, we create a listener. So Envoy has specific listeners in a namespace context to do layer 7 load balancing or path redirection, for example. And how is this different compared to other service meshes? Well, first of all, we want to reduce operational complexity. We want to make it easier. You already need a CNI. You may most likely perhaps already use Cilium, and you can just enhance Cilium by enabling service mesh, and you don't need an external ingress or gateway API controller. Also, goal is to reduce resource usage. So having not running sidecars means that you will save a lot of resources in your cluster. It will provide better performance for a number of reasons, and we want to avoid sidecar shutdown, startup, latency, or race conditions. So let's dive in on a few of those use cases. If we look at the resource usage, obviously with sidecars, you have for each spot where you enable, or each service where you enable service mesh for, you will have a sidecar running. That means that at scale, this means a lot of memory, a lot of CPU, and also a lot of TCP/IP connections being tracked for those sidecars. So that will cost resources. Moving that to the kernel frees up a lot of resources. Obviously, it's not free, but using eBPF where we can and centralizing resources as efficient as possible will save you a lot of resources in the end. There's also another cost of sidecar injection, and that is the induced latency when using sidecars. So when you see this diagram, an app is trying to send traffic to another app or service. That basically means that it goes 3 times through the TCP/IP stack. Once sending the packet, then receiving on the sidecar side, processing it in the sidecar, then sending the packet on the wire. And the same happens on the destination again. And you can see this loop takes time, and that will induce latency. How we solve this using eBPF, and this is already there for years, is that using eBPF, we can directly forward traffic from the socket layer to the network interface without traversing this TCP/IP stack. So this is an example where we only need layer 3 or layer 4 load balancing. We don't need to go through the proxy, and we can directly do, using a kube proxy replacement, do our load balancing and send it on the wire. In case we need layer 7 processing, then we need to redirect it to the proxy, yes, on the node, but we do it through the socket layer. So we're avoiding this TCP/IP stack and directly forward it to the proxy, and once the proxy has done its job, it will forward it to the data plane. This improves latency a lot. In our measurements, 2, 3, and sometimes 4 times, depending on what you use. If you use a lot of network policies or a lot of layer 7 path redirections. Here you can see it compared to Istio-based implementation. Avoiding this loop on your TCP/IP stack improves performance a lot. And it also improves throughput slightly. And also a thing to consider is that obviously at scale, when you're scaling out your applications, that also means with a sidecar implementation that you have to wait for that sidecar to be ready to receive connections, to be able to process your service and be able to serve your application. With Cilium Service Mesh, that agent runs on the node, it's ready to receive connections, it creates its listener, and it's happy to serve connections when it needs to. So today, Cilium Service Mesh can do a number of things. Traffic management is first for layer 7 traffic management, path redirection, what we are looking at today. Observability using Hubble, you can export metrics to Grafana, which gives you visibility of performance of your application. Enforcing security through Cilium network policies. By itself, it's already there for years, and now using Service Mesh, we can extend that capability. And resilience through, for example, cluster mesh topologies and such. We're not planning to develop a control plane on our own, so you can use ingress resources or gateway API resources. Spiffy is on the roadmap. We already have the data plane ready, but the control plane needs to be developed as such. And for power users today, we can also do advanced Envoy custom resource definitions. But with Gateway API, my vision is that you don't need that anymore. On the observability side, you can hook up, obviously, Prometheus, Grafana. You can instrument your applications using OpenTelemetry. Using eBPF, we can export those metrics in the most efficient way as possible. And obviously, you can export flows and data to SIEM platforms, Fluentd or Elasticsearch. Now, if you want to get started with Cilium, you have 2 choices. Maybe you already have a sidecar implementation based on Istio. I strongly encourage to also run Cilium on those clusters, because when you look, for example, at the sidecar implementation and you're thinking about MTLS between sidecars for authentication, authorization purposes, what a lot of people don't know is that the actual connection between the sidecar and the actual pod as a destination is unencrypted. Using Cilium, because we shortcut this connection on layer 4, we avoid that this connection is actually going through a virtual interface and no one can listen to that traffic. So already there's a benefit if you have an Istio-based implementation to run Cilium. And obviously, if you're creating new clusters, then you can just start with Cilium and enable the ingress controller and gateway API, and you're ready to go. So last year, we released Cilium 1.12, which meant that we released a production-ready Cilium service mesh with a Cilium ingress controller, conformed using Kubernetes ingress controller resources. You can use Kubernetes as your control plane, simple as that. We already have Prometheus metrics, Grafana dashboards, and for power users, the Cilium cluster envoy config or Cilium envoy config. And last week, we released Cilium 1.13, which enabled gateway API with HTTP routing, TLS termination, traffic splitting, and header modification. The data path for MTLS is ready. It's not yet really usable, but what you can expect is that you can use Cilium network policies to enforce, for example, SPIFFE IDs as source and destinations to allow that authentication. We have a shared load balancer for ingress resources, which I will talk a bit today as well. Layer 7 load balancing for Kubernetes services with annotations, so plain cluster IP services you can use for load balancing purposes. And a IPAM solution for load balancer services and BGP advertisement. In the cloud, you don't need it, but if you run on-prem, you most likely need to connect your load balancer IPs to the network or advertise them through BGP. This makes it really easy and flexible to advertise multiple pools of IPs to your network. So let's have a look on the features. So for starters, ingress. This is just following the Kubernetes ingress spec. You don't need an external ingress controller. And what you will notice is that you need to specify an ingress class name as Cilium. You need to enable Cilium on the Helm chart, which I will look a bit later on as well. And that's basically it. You can do path redirection in this example to forward traffic to a specific service. And this is a common example where we have a book info application where we, for example, forward the default URL to the product page and the details URL to a specific service for that purpose. We can also do ingress for gRPC, so we can specifically forward traffic from specific gRPC calls to specific services. And we can also do TLS termination using, for example, a secret you have created to do the TLS decryption at the ingress and then forward it to the services. We also released the shared load balancer for ingress resources. This makes a lot of sense in terms of cost savings. If you run in the cloud, or let's say if you want to use ingress or gateway API, you need to have some kind of load balancing solution. Cilium can do it out of the box for on-prem solutions, and then the IPs don't cost you a lot of money, I suppose, but in cloud, it does. So if you run an EKS and you create a Cilium ingress resource, that basically means that under the hood it creates a load balancer in EKS with a public IP, and obviously that costs money. If you have multiple ingress resources, they will have, previously, each one will have a dedicated load balancer, but with Cilium 1.13, you can specify it as shared using an annotation, and then you can have a shared single load balancer to have a lot of ingresses running on top of that. Then Gateway API. And yesterday there was an excellent session by Ara Purullo, sorry, about Gateway API in general. Cilium already supports Gateway API, so we can have Gateway API resources, HTTP routes. You can attach multiple HTTP routes to a given Gateway API resources, and Cilium, in that sense, is a gateway class. How that looks like is, instead of, if you look on the left, we specify a gateway resource of gateway class Cilium, and then you create one or multiple listeners for this specific gateway. And then you attach HTTP routes, where you specify the parent gateway to link it to that specific gateway. And then you can do, for example, path matching and redirects as such. Looking at TLS termination, we also support SNI, so you can have multiple host names, with multiple listeners with different host names. So in this case, we have the bookinfo.cilium.rocks, and we reference the secret for TLS termination, and the HTTP route will forward it to the required services. Traffic splitting is also supported, so you can do canary releases, blue-green releases as such, so you can slowly introduce traffic into new services using HTTP routes for the Gateway API solution. What we also enabled is layer 7 load balancing for cluster IP Kubernetes services with simple annotations without sidecars. So that means that you can specify that annotation on a given service, as shown here, and you label it as service.cilium.io label LB-LC7 enabled. That enables that feature, and then you can specify an algorithm. So in this case, least request, but we also support round robin or random. And this allows you to, for example, on a service level, load balance gRPC or HTTP traffic as such. This is also compatible with cluster mesh. So cluster mesh allows you to have 2 or more clusters together to create a single Cilium identity-aware data plane on top of that. You can use service mesh in those clusters. You can use, for example, Ingress or Gateway API to attract traffic inwards your cluster. But then you will forward it to a service, and using this service, you can also decide, I want this specific service to be high available across clusters. So additionally, the layer 7 load balancing capabilities, we can also load balance it across clusters. So super flexible and powerful. You can mix and match both Ingress Gateway API resources with service resources and load balance where you need them to be. And finally, observability. So we're partnering with Grafana. That means that we are creating, as of today, as we speak, a lot of new dashboards. You may already be aware of the day 2 operational dashboards we have already available on the Grafana marketplace to monitor and to see how your cluster is behaving. But we're expanding these dashboards to provide meaningful layer 7 golden signal metrics-based dashboards. And those data is exported through eBPF, and we are also exporting to capabilities in Grafana such as Mimir, Loki, and Tempo. So if you instrument your application using OpenTelemetry, using eBPF, we can extract that data, and we can export it to Tempo, where you will see the traces, and you can see exemplars and how the different specific span is taken. And this is one dashboard. This can be a session on its own as well, but what we're seeing here, without sidecars, using Cilium Service Mesh, we're already able to see HTTP codes. We're already able to see latency. We can see request duration. We can see, we can detect latency as such. And this is without any sidecar, without instrumentation of your application. It's already there because we have this layer 7 visibility with network policies and with Hubble metrics. That also means that we already have visibility on the network layer. If you think your application is performing fine, we also have this visibility in the network layer where we can see how many bytes are sent, we can see retransmissions, and we can also see round trip time perhaps being increasing, which can point to a specific network issue or specific node issue. So I hope I have a little bit time for a small demo to show how this actually looks like for real. So I hope in the back, I checked it a bit, it's readable in the back. Good. So how to get started with Cilium? Let me just show an example. I'm running this demo on GKE. So what you need to do is you need to enable an ingress controller if you want to use the ingress resource using Cilium. Optionally, you can enable the Hubble metrics. So I have a lot of examples here. This is all documented. You can find all these examples there. But what I'm wanting to show and what I'm wanting to see is DNS, drops, TCP, HTTP traffic. And for Service Mesh, what's important is that you also enable Gateway API enabled equals true. And finally, the kubeproxy replacement. This setting has to be set to strict or partial. We do recommend strict. That has the best compatibility and performance for your clusters. Then, I already mentioned it a bit. Then you can create gateway resources. So this is a simple example of a gateway resource, the book info example, and the HTTP routes. So now you see my environment where I'm running on GKE. Hopefully I have connection still. It's a bit delaying. Let me see. Yeah, so I'm in the book info namespace. I'm doing a kubectl get services. So here I can see I already created the gateway. I can also do kubectl get gateways. This should be able, yeah. So I have a book info HTTP and HTTPS gateway, and I get a public IP from GKE to reach it from the outside world. On the side of the application, I also have this HTTP route. So I have the details path forwarding to the details service, and the default path forwarding to the product page. So using the public IP, I should be able to connect to it. Yes, I can. And if I go to, /details, I should be able to query a specific entry, as you can see here. I also created an HTTPS example. What you obviously need to do is create a secret. I've installed that secret in my namespace, and I'm referencing that secret as well. And it's called a demo cert. Then on the HTTP route side, I just specify the bookinfo.cilium.rocks and forward it again to my specific services. So that means that if I refresh this on HTTPS, I've installed this certificate on my laptop as well, so I trust it as such. So the connection is secure, and going to this seems to work as well. So that's great. And finally, as a quick example, I want to show a blue-green gateway. So in this example, you do a blue-green deployment or canary release using weights. Again, you create a gateway. In this case, it listens for the host name myapp.cilium.rocks, also with the secret, and an HTTP route where I specify that for 80% or 90% in this case, I want to forward traffic to the blue service, and for 10% I want to forward traffic to my green service. So let's see if that's working. So I first need to change my namespace to the blue-green. Then I should be able to see that currently most of my requests are to my blue service. All right. Let's say I want to introduce more traffic to my green service. That means that I can just simply edit the weights, save it, and then apply the new configuration. That's configured. And hopefully we can now see, yes, more green services are responding to my requests. So very easy to use, out of the box using Cilium, without any external ingress or gateway API controller, using eBPF to forward traffic as such. Back to the slides. All right. So that concludes my demo and my presentation for today. If you want to know more and try it out yourself, feel free to go to cilium.io. There's a lot of getting started guides, also with the documentation about service mesh, gateway API, with examples you can try out yourself. Join us on the cilium.slack.com channel if you have questions or feature requests or would like to participate or learn more. What's also great is on the isovalent.com/labs URL, you will see that there are a lot of labs available, including Gateway API and Service Mesh Labs, so you can try this out yourself. It's based on Instruct, so you get a dedicated VM with a kind cluster on top of it, and you can see Cilium and test it out. You can even debug things if you like. If you want to know more on eBPF, feel free to go to ebpf.io. And obviously, if you want to know more about Isovalent and what we're working on, or want to look for career opportunities, please go there, and we're hiring, so have a look there. And feel free to ask me any questions you like, and I'm happy to stay around. Thank you.
Thank you very much, Raymond. It was extremely interesting.
Cool.
Before we open up for questions, are you okay to take some questions, Raymond? Mm-hmm. Before we open up for Raymond, I would like to two service informations. We have a masseur on site, so you can get a massage, is in the sponsor area. No? Okay.
But thanks.
The second one is we're going to have some Q&A with Raymond. Afterwards, we are going to have a little break and lunch. So you guys have some time to stretch your legs and to speak with our great sponsors. Please speak with them. The lunch is going to be served in the sponsor area. That's it. We're going to restart with a person that is actually very, very dear to me. My brother Lukonde is going to start 1:45 here. Now, questions for Raymond.
Hello.
Hey.
Thank you very much for the presentation. I would like to ask you regarding the possibility of the multi-cluster, because you showed that there is the option to set up the global, but I don't really get, like, how do you do that? Do you have a separated installation for Cilium outside the clusters, connected to multiple clusters? How do you do that?
Yeah, so first of all, you need to meet a few requirements. So let's say you're running 2 clusters on AKS in different zones or regions, whatever, and you want to connect them. You need to have layer-free connectivity between them, either through gateway or through VPN. And so the nodes can reach each other, and that the API server is available in each cluster to listen to requests, read-only requests from another cluster. Once you've done that, you can either use the Cilium CLI or specific Helm values to enable cluster mesh. And what it looks like is that you basically create a unique ID in each cluster. You will specify the main CA to sign certificates for the agents to have TLS connectivity with each other. And then they will be meshed, right? So the CLI is super easy to use, but we also have documentation how you can use that with Helm. And then basically, there's one data plane. One cluster learns from the identities from the other cluster and the way around. And when you create global services in each cluster in the same namespace, Cilium under the hood using eBPF will populate load balancing eBPF maps with those IPs of endpoints and will load balance traffic across through the nodes to the other nodes and then forward it to the destination pod, for example. So super easy to use in that sense. So the documentation is out there and should be self-explanatory as such.
First of all, thank you for a great talk about the very comprehensive description of the novel service mesh approach. I have a small question, because you mentioned that there are several quirks that one has to take into account when deploying the service mesh. What's the environment that you would recommend in order to try out the service mesh, for example, to compare with the other solutions like Istio or Linkerd, without having to deal with quirks of the deployments of, let's say, cloud providers?
So you can try it on kind clusters, if you liked, on your laptop or Minikube. With kind, you may need some Metal LB implementation, or you can use the Cilium built-in load balancing capability to try it out yourself. You can also perhaps run a little cluster on VMs, install Cilium. You just need a 4.9 plus kernel. So if it's Debian or Ubuntu, doesn't matter. You create a small cluster, install Cilium with the Helm values I just shown, and that would set you ready to use service mesh as such. And again, on-prem, you will need this load balancer. So you should enable the Cilium load balancer to be able to allocate IPs, to attract and attach the load balancer to your ingress resources as such. So I recommend to check out this lab. We have a Gateway API lab and a Service Mesh lab. You can also earn a badge when you complete it. And this lab runs kind on Instruct VMs. So you can actually see it working without trying to run anything in a cloud or whatsoever.
Thank you.
You're welcome.
Okay, do you hear me correctly?
I do.
Okay. Hey, thank you, by the way. It's a nice product. But now I've got some questions, and I'm not trying to critique you here. Okay. But you talked about the sidecar solution and that this is an alternative. Yeah. And then you showed the performance improvement in latency. But then showing us the throughput, it didn't relate very much. Can you explain that?
Well, can I explain it? I mean, you get a little bit of benefit of the TCP socket layer connectivity through the sidecar, but you still have to get the throughput on the same TCP stack leaving the host. So that's limited perhaps by speed or as such. So you don't gain a lot there, but it has small gains for sure. So yeah, that's my explanation perhaps.
Okay, that could be a thing.
Yeah.
But the thing on my mind here is eBPF itself. You will see a lot of applications that start using it. Cilium is an example of that. In Kubernetes, we've got something like the OOP that kicks in if your CPU is getting used. In your kernel, this is not really tracked. Could this not be a vulnerability in the fact that if there's is a lot of traffic in a node, how would we see that?
So I reckon
if Cilium is a limiting factor there.
Yeah. Okay. Yeah. So one best practice is not to constrain Cilium and Cilium agents as such running on a node using resource pools, etc. Don't do that because that will at some point break it. But obviously, if you push more traffic, if you do more load balancing, yes, of course you will see an increase of CPU being used. You can track it, however, using our already available Cilium dashboards, using Grafana, for example, and you can see how an agent is performing. You can see if there's BPF map pressure, or if you're running out of memory or CPU on the node level. So you can already use those metrics and those capabilities built in to monitor the performance of your nodes of Cilium and your cluster.
In load, yeah, okay. Well, it could not be that that's if it happens in user land, that's nice. But if your kernel, because all the processing in the kernel, no priority, goes straight to, it could be your breaking point.
Yeah. Yeah, that's one reason why we also launched Tetragon, because we can also use Tetragon in combination with Cilium to do the kernel visibility. So that's next level, I would say. It's not something I yet see implemented as such, but we can actually monitor BPF calls and BPF and kernel as events as such, and just the performance using Tetragon. But that's another solution you need to run on top of that.
Are you okay to take two
Absolutely,
more questions?
Yeah, keep them coming.
All right, thank you for your presentation. I was wondering, Amazon has its pretty specific VPC CNI with all the IP juggling. Can Cilium integrate with that or even replace it? Any
Yes.
pitfalls there?
You have a choice here. First of all, you can use Cilium as VPC CNI chaining mode. That means that you leave AWS for IP allocation, the ENI allocation to the EKS nodes, and some other IP-related things. And on top of that, Cilium can do the enforcement using network policies, et cetera, So you can use service mesh capabilities as well. But you can also deploy, provision your clusters in EKS or AKS or GKE still with bring your own CNI or with specific flags not to provision the AWS CNI, and then install Cilium yourself, and then you have the full feature set available and compatible running on EKS.
Okay, thank you.
Welcome.
Raymond, I have one more question, and then I have a question of my own, if you don't mind.
That's fine, I'm here.
My question is, so in the proxy-based service mesh, we as a user get to see which applications use service mesh.
Yeah.
So only those parts of only those applications will get the sidecar inserted.
Yeah.
In this case, it is at kernel level.
Yeah.
Does it mean that we lose that flexibility, and whether or not we want it for one or the other application sitting on the node, it gets applied to all of them?
No.
And if that is the case, then what about the performance?
No, it's not the case. So it's only the case for, let's say, this specific service when you enable this layer 7 load balancing in a given namespace. That will mean that only for this given namespace we create this envoy listener on the node, on the agent, but not for everyone else, right? So it's dependent on where you enable it. So it just unlocks this ingress controller and gateway API controller. You can use it, but only if you specify it either as an ingress resource, gateway API resource, or use the load balancing service cluster IP annotation. Then it will use it, not before that.
Raymond.
Yes.
First of all, I would like to congratulate you and Cilium team for 2,101 commits for release 113.
Thank you.
That was impressive.
Yes.
It's packed with goodies. I have played with Cilium, and I still implemented the customers a lot. And I have tried out the cluster mesh with 2 clusters only. What I miss is a single pane of glass on Hubble and a third something that allows me to observe the service mesh into one place. It's in the same look and feel that Cilium always gives, like everything, batteries included. Is that in the planning?
Well, that's a tricky question in the sense that we do have it available as an enterprise Hubble UI. So yes, Hubble UI is limited to what you see. You can see the identities from different clusters. You can see, you can secure it as such, right? You can use the cluster ID as a source or destination in Cilium network policies. But the visibility layer is in the Hubble UI enterprise solution.
Well, thank you very much.
Yeah, welcome.
I have the feeling that it was very interesting for all the people that are still sitting here, still looking at you. I don't know if they want to find you in the back room to
That's
eat
fine.
you or something else. but thank you very much, Raymond.
Thank you
It
so
was
much.
very good.
Thank you. Thank you.
Okay, guys, you are free. You were always free, but you chose not to be. So we're going to see each other later for a look on this talk at 1:45. Enjoy your lunch.
Hihihihihihi.
Super. Nou, bedankt hè.
Blijven die in elkaar of gaan die... Wij zijn tot 5:30. Blijven jullie schermen in elkaar of in een kist? Ze moeten in de kist. Maar deze zaal heeft er als allerlaatste prioriteit, denk ik. Ik ga alvast even beneden kijken. Doe dat. En alvast even het eten op de tafel neerzetten. Ik ga even toiletteren. Ik ben zo druk. Deze. Maar ik ben toch eerst een account maken. Ja, precies. Oh ja, ze moeten nog een inloggen.
using to call again?
Google Meet.
Google Meet. Okay. I'm not sure if
Just meet.google.com.
Is this also where one should go to get mic'd up?
Sorry?
Is this also where one should go to get mic'd up?
Yes.
Question mark?
This lovely man will mic you up.
Yes. Hi.
Later.
Yeah. First lunch.
First lunch.
First lunch.
That's fair enough.
So yeah.
Download this.
It's very dramatic.
This was already
Just
the third iteration of this.
meet.google.com.
Yeah, but it didn't show me the download link.
That's okay. So if you click new meeting, it's not downloading. It's just in
it's
the
not
browser.
Alright.
So start an instant meeting, the second one. Yeah. One second. Now my phone decides to be slow. I'm going to ask to sit on stage, and I'm going to stay up here with my phone and dial it. Go up there so I don't get feedback.
You can just turn down your volume.
Do you have a handheld or something downstairs?
Yeah, they're in the corner.
Okay.
On
So,
the.
do you want me to just go?
I need the CHB. Okay. So join. Yep. CHB dash
Oh,
AHMT.
Yeah, BPS.
There we go. I've joined. So you need to let me in.
Yeah.
Yep. Yep. No, I can see the stage, which is good.
Yeah. We need your audio as well.
Right now I'm here with you at the laptop.
Yeah, I'm going to switch that. Wat wil? De inputs. De audio. Had ze goed staan? Oh ja, oh, dan is het Google Chrome die Zeg niet dat het nog goed is. Oh, wacht. Daar, die moeten we hebben. Teksttoon. Oh, ja, oké, share. You have to press the, I think it's turned off, or not. Is there a red light on? Yeah, 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 no, it's correct. No, that's fine. Yeah, and push the red button. Yeah, the LED. Yeah, no, you're good.
Hello? Ooh. I expected it to go green. UX, I don't know.
Hoor ze beide op de headset? Zullen we het zijn? Ah, yes, dat is die. Can we try your... Ah, there we go.
Andy.
can hear you. I can't see you though. Oh, I can see up your nostrils, Andy. Look at you. Hello. Yeah, I can hear you, all right? Can you hear me? But can you hear me from the room, or can you hear me from
Good afternoon, everyone, and thanks for coming back. One always fears that people are not going to come back after lunch. We have Lukonde from. We used to work together with Lukonde in the same company, and then he decided to leave paradise and jump in hell. No, it's just AWS. Lukonde, please give it up for him. Thank you.
Thanks, man. All right. Hello, everyone. How are you doing? Looks like people are cold. I'm not the only one feeling it. I'm kind of hoping being up here will warm me up a little, unless I'm just delusional. So thanks for coming to the talk. As you can see, I'm going to be speaking about spreading applications, controlling traffic, and optimizing costs in Kubernetes. As William already pointed out, my name is Lukonde Mwila, or you can also call me Luke, and I'm a developer advocate for Kubernetes at AWS. So if any of you want to get in touch with me, you can feel free to do so. You can reach out on LinkedIn. I use my full name, so you can search for me. Hopefully you'll be able to recognize me. Also, I produce a lot of Kubernetes and cloud native related content, and you can search for that on YouTube. Subscribe to the channel if you find it interesting. But also the developer advocacy team that I'm a part of has a dedicated YouTube channel called Containers from the Couch. Similarly, lots of great content that would be useful for you and your teams. Great, we're going to jump right in. So this talk was inspired by a combination of things from the past and the present. The first one being an event several years ago on a specific Black Friday. And at the time, I was working as a developer for a software company, not the same one as William. And all the developers worked together in a shared open space. So from my vantage point, I could see the screens of some of my work colleagues. Now, because it was Black Friday, as you'd expect, a number of my work colleagues were especially excited to take advantage of the discounts on a particular e-commerce website. And that site was really popular amongst most of the folks at the company. Unfortunately, on that day, some of you might know where this is going, the site crashed. And I could see this from where I was seated. My work colleagues that were trying to access this site were all met with the same screen. And the company had essentially issued out an apology letting people know that their systems had crashed due to a high volume in traffic. They didn't have that bit there about trying to restore balance in the Force. I'm a Star Wars fan, so I threw that in there. So just for the sake of historic accuracy, that wasn't there. Now, when you experience something like this as a developer and you're the end user, or even if you're just involved in software architecture and you understand it to some degree, you can't help but ask yourself the question, what would I do if I was in that position? Or how would I have prevented that kind of situation? You can kind of empathize with the people involved in that situation because you're also involved in software. So naturally, it spawned a lot of discussions between myself and some of my work colleagues at the time, but even over the years because it was a relatively significant incident. And the general consensus from a lot of those discussions was that if you want to prevent something like this, then you should probably have some form of high availability and auto-scaling mechanisms involved in your architecture. Now, I just want to be clear, we didn't have context as to what the root causes were. So we were basically guessing, but that was a safe guess in terms of the kind of measures that you want to have in place to mitigate the risks of such an outage, especially for a business of its stature and on such an important day. Now, I want to start off by focusing on high availability before I get to auto-scaling. And these two components today are widely considered best practices. They're relatively standard or common patterns, and in many ways you think of them as straightforward. But you need to give ample thought to both high availability and auto-scaling because they come with implications. And the implications that I want to focus on are the cost implications. And so it's all fair and fine to have a highly available architecture, and these architectures are generally fronted by a load balancer that proxies traffic to different upstream servers or destinations. However, you need to give thought to the load balancing algorithm or approach that you're taking in these kinds of setups. For example, if you're going with a round robin or a random approach, you need to be aware of the fact that that means that you're going to have a lot of egress cross-zone traffic. And this is one of the points where you incur a lot of costs. And this is something that has been coming up a whole lot with some of the teams that I've been engaging with. especially in cloud contexts. And so high availability is important because it addresses a resilience issue. You want to eliminate having a single point of failure. In addition to that, it improves performance by essentially taking care of the fact that you don't want to have a minimal number of resources that get strained. But bearing that in mind, you need to be aware of what your particular constraints are for a particular project in order to implement the solution in the best possible way. So there are a lot of costs associated with the load balancing strategy. In addition to that, we also have to consider auto-scaling. So this traffic that is being proxied from the load balancer is headed up to upstream destinations. And one of the other common pitfalls is wasted compute capacity. Even while I've been here speaking to a couple of people who shared that they've also been seeing this a whole lot. Do your nodes actually align with the workload requirements? And so auto-scaling is important, but another thing that we see that happens a whole lot is over-provisioning of compute capacity. And so it's great that now your infrastructure is essentially scaled out to accommodate those events where you need to scale. However, there are situations where you've provided a whole lot more than what you actually need. The reason for that is probably using a cluster autoscaler that has a more static approach, working with a scaling group in the particular cloud provider that you may be working with. So these two areas incur you a whole lot of costs, and now it's a whole lot more critical because we're in a difficult economic time, and a lot of teams do want to take advantage of high availability of their workloads and their infrastructure with Kubernetes, and they want to achieve that in a cloud environment because of what it has to offer, including the elasticity they can get, but they're also trying to find the best ways to address the operational costs associated with such a model. And that's what I'm going to be focusing on. So the first thing that I want to look at is spreading of your application. And there are two different features that you can make use of in Kubernetes in order to spread your application. The first one that I want to focus on is pod affinity rules. And so pod affinity rules are how you can essentially apply scheduling constraints through the form of certain rules that define a relationship between different workloads. It could be the same workload as well. And that's what you'd essentially want in the case of achieving high availability. And so these specific rules influence the scheduler's behavior when it's placing pods on nodes. So if there is a specific affinity rule between pod A and pod B, or rather let me say workload A and workload B, and the scheduler has already placed workload A on a specific node, depending on the affinity rule that you have defined, when the scheduler is about to place a pod on a specific node, it's going to look at that relationship and see whether or not it should actually be placed on the same host or whether it should be on a different AZ. And these rules are based on topology domains. And the topology domain can either be a host or an availability zone. Now, what we're interested in, as you can see in this diagram over here, is an anti-affinity rule. So an affinity rule would essentially be if we want our pods in close proximity, whether that's based on a host topology or if we want them to be in the same AZ. With anti-affinity, that's essentially wanting to have somewhat of a repelling effect. We want the pods to repel each other so that they're spread across the different topology domains. And so that's how we would achieve high availability with our application. Next, I want us to consider pod topology spread constraints. So this is the other approach. Now, pod affinity rules, or rather pod anti-affinity rules, can help you achieve high availability, but the issue with them is that it doesn't necessarily address, or rather it introduces a problem of fault tolerance. Pod topology spread constraints not only provide you with high availability, but also deal with the issue of fault tolerance. It gives you more control over how you actually want your pods to be distributed across the different topology domains in your cluster. So if you take a look at this diagram over here, you see that we have 10 pod replicas, and they're close to even when it comes to doing this in 3 different availability zones. We've got a spread of 3, 4, 3. So this is something that you can't really achieve with pod anti-affinity rules, and the reason for that is because they have an anti-affinity toward each other, so you could easily end up with a situation where you have a single replica running on a node, which is not good for fault tolerance, and it's not good for resource utilization either. So this works out a whole lot better if you're trying to not only address availability, but also fault tolerance of your workloads. And because this is the one I'm going to be showing you or demonstrating a little bit later, I'm going to focus on the kind of properties that you would be defining. So these are the properties that you would primarily be concerned with if you're going to use pod topology spread constraints. I'm going to start off by focusing on max skew. And max skew is how you would define the maximum point to which you want imbalance or inequality for the distribution of your pods across the different topology domains. So if we take the example from the previous diagram, just going to go back quickly so you can see that. So that's 10 replicas for 3 different availability zones. There's no way to equally spread the number of pods, but what we can do is say we want a maximum imbalance or inequality of 1, which is why we've got 3, 4, 3. So that could easily end up also being 4, 3, 3. Now, the max skew can be anything between the value of 1 and the number of replicas that you have. So in that case, it would be between 1 and 10. So if you went with 10, then that means there'd be a chance of which you end up with 10 replicas in a single topology domain, whether that's a host or an availability zone. And you'll see over there, there's also the topology key. And this is the key that's going to be attached to the nodes. It's going to be one of the labels, and it's how you essentially define the kind of topology that you want to work with, whether you want it to be a zonal approach or if you want it to be a host. And when unsatisfiable is somewhat self-explanatory. This is how you want the scheduler to respond in the case that it can't meet these scheduling constraints. So if you want it to still go ahead and schedule the pods anyway, or if you want those pods to remain in a pending state. And then lastly, we have the label selector, and this is similar to pod affinity rules. And in this case, it's essentially saying which pods, or rather, any pods that have this particular label or these labels are the ones that have the relationship for which these constraints should be applied. So that's pod affinity rules and pod topology spread constraints. That would be how you would achieve availability of your application. But the next thing that we want to consider now is to start addressing those 2 main areas of optimizing our costs, the load balancing area, and then we'll get to the nodes a little later. But let's start off with controlling traffic. And I'm going to demonstrate, or rather speak about 2 different approaches that you can take. The first approach I'm going to discuss will be through the use of Istio. For those who aren't familiar with Istio, it's an implementation of a service mesh, and the job of a service mesh in a nutshell is essentially to unburden applications from having to deal with networking concerns. And they generally do that in these 4 main domains: connecting of the applications, securing those connections, controlling traffic or traffic management. In addition with that, also adding resilience mechanisms, and as well as having observability features. Now, what we're concerned about in this particular case is controlling traffic. So changing the way load balancing is actually going to work. So if we look at the diagram over here, you'll notice that we have a request that starts from a particular end user, and their request goes through to the load balancer that is exposed by the Istio ingress gateway. That traffic then gets proxied to that component there that says virtual service. The job of a virtual service in Istio works a lot like ingress. So if you're familiar with the ingress resource, this is essentially how routing takes place. You define your routing rules using virtual services. After routing takes place, you can apply additional policies, such as what we're actually about to carry out, which is controlling the traffic, and you would do that with destination rules. And with the destination rules, what we can actually do is essentially say, for traffic coming from a certain point of origin, we want it to go to a certain destination. And so some of you might already be familiar with these concepts when you think of different deployment strategies, directing a certain amount of traffic to a certain version of an application for either a blue-green deployment or a canary deployment. But in this case, what we actually want to be doing is taking advantage of Istio's feature known as locality-weighted load balancing. And if I'm correct, other service meshes also have this. So Istio essentially takes the information of the topology domains in your cluster and uses that information in order for you to actually carry this out. So for a load balancer, which is highly available, and I'll demonstrate that a little bit later. So let's say we have our cluster running in the region EU West 1, and we've also got a load balancer that's highly available, so it's across 3 different availability zones, EU West 1 A, B, and C. Traffic that hits that particular load balancer, we want to configure it in such a way that we say for traffic coming from EU West 1A, it should go to an application that is running in EU West 1A. And we can determine how much of that traffic goes where. So in this case, you'll see with this particular diagram, I'm saying 60% of traffic to EU West 1A, 40% to EU West 1B. And this is a powerful mechanism because this is one of the ways that you can drastically reduce the egress traffic costs. So I think some of you are probably being kind and just nodding your head as I was talking about Istio, because I know there's sometimes not so much love for Istio because of the operational complexity associated with it. And it's totally understandable. But something that has been interesting while these kinds of issues have been coming up and I've had the chance to engage with different teams, they've essentially been faced with two main options. It's either they go the approach of using the destination rules that Istio has to offer, or they accelerate upgrading their cluster to a point that they can make use of topology-aware hints. And if I'm correct, topology-aware hints hit a beta level as of 1.23, and I think it's still in a beta state. But you might have situations where some teams are running older versions of Kubernetes, and so they can't make use of topology-aware hints. But I still want to speak about it so that some of you may be aware of that in case you're running a version that allows you to make use of this feature. And just for a bit more context, I'm going to go through how the process of routing traffic happens when we're load balancing for our particular applications. So we've got services. Again, most of you, if not all, are already familiar with this. And our services are a stable network abstraction layer that sit in front of our pods because our pods are ephemeral, so they have a static IP. Now, because our pods have a short life cycle, those IPs are continuously changing. But when those pods are actually alive, their IPs are stored in what are known as endpoints. And every time that a service is created, there are endpoint slices that get created. And those endpoint slices are created by the endpoint slice controller. And the endpoint slice controller is what's actually responsible for allocating the different endpoints for the IPs to the different topology domains in your cluster. And so if you have a highly available cluster across EU, West 1, A, B, and C, the endpoint slice controller is going to be responsible for allocating the different endpoints into these different topology domains. Now, when you do that, the next thing is the kubeproxy is a daemon set that's running on each of the different nodes. And the kubeproxy is also serving a form of internal routing. And what it does is it consumes from the endpoint slices. Now, outside of topology-aware hints, each of these endpoints just has information about the specific pod, its IP address, the node that it's running on, and any additional topology information. But when you have topology-aware hints enabled, this is what happens. So you can see without hints, the endpoint slices have endpoints that essentially say we serve traffic for just about any zone. But when hints are enabled, it essentially there's an endpoint with a specific availability zone based on the one where that pod is actually running. So if we have a pod running in EU West 1A, that information is stored in a particular endpoint, and then the endpoint slice controller is going to add a hint saying that you should serve traffic coming from EU West 1A. So that's the mechanism to essentially control traffic to be within a specific zone to minimize the costs associated with egress cross-zone traffic. So those are the two approaches. Hopefully that helps you with when you're trying to consider which approach to take. Again, having a service mesh does come with operational complexity, additional domain knowledge, and it might be a case where your team is not in a position to take on that. Alternatively, if you decide to go with topology-aware hints, you just need to be aware of the specific version of Kubernetes that you would have to be running in order to take advantage of that approach. But the process of actually getting running with topology-aware hints is really simple. It's just ensuring that your nodes have the relevant topology domains. And if you're running a Kubernetes cluster in a cloud environment, that automatically gets generated for you. Those topology domains are attached as labels to the respective nodes. And then you would simply need to add an annotation to the service that you want to have actually managing the service that's going to be proxying traffic to the different pods in order for hints to work out. All right, so then lastly, before I get to the demo, I want to turn to managing nodes. So just by show of hands, has anyone here heard of Carpenter? Okay, great, a couple of people. And who here is familiar with the Kubernetes cluster autoscaler? Okay, most people, which is great. And it's a fantastic project. And several years ago, before I was in developer advocacy and was still consulting, that's the project that we primarily used. But a challenge that we run into then was the fact that the cluster autoscaler takes a static approach to scaling. It works specifically with an auto-scaling group in a particular cloud environment, whether you're using AWS or Google or a different cloud provider. And so this can be particularly challenging when you're trying to deal with the whole issue of reducing costs and improving resource utilization for the underlying nodes. And what Carpenter does differently is the fact that it's more dynamic, and instead of working with a scaling group, instead it looks at pods that are in a pending state and takes into consideration their specific pod requirements as well as their scheduling constraints and then reaches out directly to the EC2 API in order for it to provision the nodes that are actually needed for those particular workloads. And so this drastically improves your resource utilization as well. In addition to that, Carpenter also has a feature called workload consolidation. When workload consolidation is enabled, Carpenter is continuously monitoring the nodes in your cluster that it controls to see whether or not resource utilization is at a good level. And in the case that in the case that any node is underutilized, then it will essentially remove that node from your cluster and consolidate things to make sure that there is improved resource utilization on the nodes that are actually needed in order for you to save on costs as well. Now, obviously, the big challenge with Carpenter is, even though it's an open source project, at this particular point in time, there's only support for the AWS cloud provider, so there's still an open issue. So this is also somewhat of an invitation for more people to get involved with the project in order for it to be extended to additional cloud providers as well. Now, one of the other things that I love about Carpenter is the fact that it also respects scheduling constraints. So to circle back to where I started from in terms of high availability, when you put particular topology spread constraints in place for your workloads, Carpenter will be able to respect those things when it's adding nodes to your cluster. All right, so that's the talk. What I'm going to do now is switch to a demo to show you a specific focus on controlling traffic. I'm going to zoom in a little here. Okay, can everyone see that clearly? Great. So the application that I want to focus on is a basic Node.js application. And so it's actually two different versions of the same application. And the reason I'm doing that is because they're going to give me different responses for the exact same endpoint. And I just want to be able to differentiate between the two different applications when traffic is being proxied to see whether or not our destination rule configurations are actually working as expected. So I'm just going to scroll down slightly here so you can see that. You'll notice that we have one application that is using version 1.1.2, and this one is called Express Test. If I scroll down further, this is Express Test 2, and Express Test 2 is running 1.1.4. Now, both of them have topology spread constraints applied. Now, if you take a look at this, you'll see that this is the exact same code block that I walked through earlier when I was talking about topology spread constraints. In addition to that, I've got a node selector to ensure that these pods are only placed on nodes that are added by Carpenter. So that's our application, and they're going to be fronted by a cluster IP service that proxies to those two different applications, treating them as if they're the same one, or rather two different versions of the same application. And then next over here is a custom resource definition file known as a provisioner. So this is the file that would essentially control the life cycle of your nodes in Carpenter. And you can have multiple provisioners, or you can have a single one. So in this case, I've got a provisioner dedicated to my Express Test workload. As you can see here, it's called Express Test. And you can apply different parameters or constraints for how you want Carpenter to add nodes to your cluster. So in this case, it's already defined to add nodes to every one of the availability zones. In the case that you wanted to add constraints to that, you can do that. If you want to restrict it to only adding spot instances, that's something that you can also apply. In my case, I want both spot instances and on-demand instances. And you can also add further configurations like defining the instance families you want, which is a really powerful feature because obviously there are certain instance families that are more costly than others, and so you can be able to manage that. And then right at the top here is consolidation, and you can see it's enabled. So remember, this is that feature that I spoke about that allows Carpenter to continuously watch your nodes to ensure that it's checking whether resource utilization is at an optimum level, so that it also just keeps working to reduce your cluster costs and removing nodes that aren't needed. All right, next up over here is our destination rule. This is that custom resource definition file for Istio. And as you can see over here, I'm just going to focus on the distribution section. And you can see what I'm saying is for traffic coming from EU West 1A, I want 80% of it to go to EU West 1A, and 10% to B, and 10% to C. And the other sections are very similar. 80% of traffic coming from EU West 1B should go to EU West 1B. So this is basically minimizing the amount of cross-zone traffic. And then real quick, just to show you, this is the script that I'm going to be running. They're all sharing the same Istio ingress gateway. And you can see that's the endpoint I'm going to be accessing, because remember, I have those two different versions of the same application. So the requests are going to be sent there, and it will go through that same flow from the diagram that I had up, virtual service, destination roles, and eventually through to our application. So let's see what this looks like. Okay, actually. Before we get to that, before I run it, just want to quickly show you. Over here is Express Test 2. It's already running in my EKS cluster, and we have Express Test 1. Express Test 2 is running on this node over here. You'll see 2165, and Express Test 1 is running on 0087. Just want to quickly come here so you can see that. You see we have 0087 over there. I'm going to describe that, and I'm going to scroll down. And I just want to highlight this particular thing to you. So you can see there, this particular node is running in EU West 1A. So that's where one of our applications lives. And then this is our other Carpenter-controlled node. If I scroll down, you'll see that this one is running in EU West 1C. All right, so next thing I'm going to do is simply run this load balancing script. There we go. So we've got responses of version 1.1.2 and some from version 1.1.4. Now, if we're honest, it's really hard to deduce that the destination rules are actually working. For all we know, it's just a random approach. So the best way to verify this is to actually go back to our code editor and modify the destination rules. And instead, what we're going to say is we want, regardless of where the traffic is coming from, we want 98% of it to be sent to EU West 1A. So I'm going to apply this to each of them. Oh, that's wrong. Going to apply that. Okay, so that's configured. Run the load balancing script again. And you'll see now, this time we're just getting version 1.1.2. So that's just one way to verify to ensure that our destination rules are actually working as expected. Great. All right, so I'll move over to a bit of time of Q&A now.
That was brilliant. Thank you, Lukonde. Do we have any
Sure.
question for Lukonde? Yes, we do. Oh, thank you. Thank you.
Yeah, thanks.
Thank you for. Can you hear me?
Yes, loud and clear.
Thank you for your talk. I just wanted to go back to the Carpenter config, specifically under the topology spread constraints. And I noticed you set a condition to schedule anyway for when unsatisfiable, and I feel like that kind of introduces variation, right? And some things might just slip under the bus. Was that intentional?
Yes, yeah, no, that was intentional. So again, it's going to depend on how critical your workload is. If you're fine with having those pods ending up in a pending state, then you can essentially change that value to a different approach. So it's totally up to you, depending on the type of application you're running and how critical it is to continue running. Obviously, the desired approach is to have high availability across your different topology domains, but then this is an attempt by the scheduler to take those rules into consideration when it's applying them. So it just comes down to how do you want it to respond in the case that those constraints can't be satisfied. Yeah.
We have more questions, I suppose? Yes. left one first.
Look, thank you very much, first of all. I would like to ask you something related to Carpenter, because I've been using it in production for a client of mine.
Yeah.
And one of the issue I find out is that while Carpenter worked really well with scaling regarding like memory or CPU or this kind of statistic, disk space is actually a problem. Like I had a node crashing, like application crashing, just simply because the node the disk space was not enough and stuff like that.
Right.
Is that something that it's possible to monitor with Carpenter and handle this kind of problem too, or no?
Yeah. So in that case, I think it's probably best to make use of an observability stack in that situation, because you want to take advantage of tools like Prometheus and have that be monitoring what's actually taking place on your particular nodes, and rather be sending alert messages so that you're aware of it. In terms of optimizing those particular nodes, probably just making sure, if it's a case of disk space, making sure you have the right amount of storage in place for that, and also just reviewing the instance families as well. Yeah, those would probably be the two main starting points. Just reviewing the disk storage space that you're actually using, trying to see what exactly is consuming that quickly, and better yet, making use of the observability stack to actually monitor your nodes.
Thanks for the talk.
Yeah.
I have a question regarding when you're talking about the topology spread, like in the beginning, and the fact that we have quite a lot of information on where our workloads are actually deployed in which zone in the given cloud provider. We have this information on the pods because pods are in the nodes, and we also have this resource called the endpoints. So we know how where to route our traffic so that it ends up in the particular availability zone. However, I also noticed that in one of the configuration files, when you were showing how to set up Istio, you had the configuration on, basically you had the paths configured in such a way that there were names of these zones in the paths.
Yeah.
So my guess is that there is no information right now on how to, at least in Kubernetes, like vanilla Kubernetes, on where the traffic comes from. Like this has to be done on the external load balancer, like either on premises or provided by the cloud provider, right?
Right, I see what you mean. Yes, that's correct, yeah.
Okay.
So in this case, because I knew that my load balancer, it's an external load balancer created by the Istio Ingress Gateway. It's an EU West 1, and so that's why I was able to implement those specific rules.
Thank you.
Sure.
Thank you, Lukonde.
Yeah.
That was last question. We are a little bit off schedule at the moment, but we're gonna come back with it. I'm going to be very selfish, and I'm gonna ask Lukonde to have a photo with me.
All right. Yeah.
Thank you.
Sure.
Thanks.
Cool. Thanks.
Thank you very much. Thank you very much. Please give it up for him. Okay, we are back in schedule now. We're gonna have the next talk in 10 minutes at 2:30. So please don't leave my room, or call your friends to come upstairs and have a fuller room. Thank you very much. Sorry, guys, sorry, don't leave. I have one request, please. Some people are feeling cold, don't understand why, but downstairs, if you leave the building, can you please pull the door closed behind you? Simple as that. Yeah? Thanks. Here we are again. Before we start with the next speakers, I would like to thank one more person. I'm not going to thank you guys. I would like to thank one more person up there doing something that we actually don't see around here, but we have a stream online. It was last night. I couldn't sleep, really couldn't sleep. I was freaking out, and I started seeing on YouTube videos, and we were there for 6 hours straight. Beautiful shots, and it's Salman upstairs doing a lot of work. Thank you very much, mate. Thank you. All right, our next speakers, Jurgen and Dinant, use case from the municipality of Amsterdam. Give it up for them, please.
Very good. Thank you. Good afternoon, everybody. Amazing to be standing here. So, yeah, awesome. Yeah, you, okay. Yeah, no, let's start with the introduction. I'm Jurgen Allewijn. I work as a lead consultant for Luminous, and I also work now for the city of Amsterdam as a lead architect for the cloud platform. Yeah, my name is Dinant Paardenkoper. I'm also a solution architect and a system engineer, and also working for the gemeente Amsterdam, and my company is IT Impressive. So, yeah, let's first start with the organization, a bit of background of the city of Amsterdam. So, yeah, a bit of who we are. City of Amsterdam is has 18,000 employees. We have, of course, the city council, the political part, but we have 80,000 civil servants working for the city of Amsterdam. We are separated in 4 clusters with 42 direct management teams, and one of the teams of the clusters is IT, and that's about 1,600 people. So it's quite a big organization, and I'm not sure if everybody has that idea when you're talking about the city or local government. So quite big. Yeah, we started with a new IT strategy as a city of Amsterdam because we want to move to the next phase, and so we asked the usual suspects like Gartner to tell us what we want to do. It turns out that it wasn't the same as we were already planning, but yeah, if Gartner says it's okay. So we decided that we wanted to go cloud native. And we decided that we want to have a multi-cloud strategy, but first start with one. So we focus now on Azure as our first. We also have a strategy of SaaS before PaaS, before IaaS. So all the Azure components are mainly PaaS, and some of them are IaaS, a small part. We use only general available features. That's very important for later in the story. And we do everything as infra as code. Yeah, we set also as architects, we set up some cloud principles. They are based on our cloud strategy. Yeah, you see the list here. I think the most of them are recognizable, like you build it, you run it, you own it, start small, automate everything, but also security and service management, compliance by design. So all those things should be part of all our solutions. And of course, we also have to comply to several compliance standards, like the BO, which is the government compliance standard, but also we are using the security control framework from Microsoft and the modern service management control framework also from Microsoft. And we have the PIA, which is about privacy, and the government standards like NORA. So there's a lot of compliance standards which we have to take in account when we deploy something. Then the question is, of course, why shared AKS? That's our business case. And from here, we want to take a look from our workloads perspective. We have around 40, I heard, most of the time of you.
And costs and compliancy, that's already told, but also security we want to get in place. And we saw a lot of popping up different kind of AKS environments without any maintenance and trouble, basically. So I want to take that into account with you. So looking to the workloads, we see a lot of people that want to embrace basically the elements and the features of AKS, but also other technologies in Azure, like the data platform and the Databricks and that so on, but that's for another other use case. But most of them, they were experimenting with containers. So we wanted to embrace them that they are doing so. Also, we are doing the way of DevOps working. It's more or less common nowadays, but most of the teams do have to change to that way of work. And we wanted to centralize our Kubernetes experience because they are very rare at the moment looking to the market. Looking to the other elements like cost and security, I think those are most common nowadays. Everybody has to try to keep the costs in place. But most of them we're trying to achieve, and setting also FinOps, that's one of the elements that we are doing also. And we're trying to centralize basically all those loosen AKS clusters to have not costs running everywhere, but a little bit centralized. And if you have some centralized platform, you have the possibility also to take into account the compliancy and the automation by itself. Then the technical side, we had a little demonstration of one of our speakers yesterday, Christina. Thank you for that. We're going to dive a little bit deeper, but most of them, it's obvious, of course, Kubernetes of itself. There were a lot of functionalities in technical preview 1.5 years ago, so we faced a lot of issues like, we cannot solve it. So for that, we had to do some tricks and elements, so that we will take further in our presentation.
Yeah, so when we started, we needed to have a plan of action. So first we started with the architecture, look at all the standards, then we looked at the design decisions and documented them, and then finally we had a solution that we could build. So if you look at the architecture, as a base we use the Cloud Adoption Framework from Microsoft. We also comply to the well-architected framework from Microsoft. We had last week, 2 weeks ago, we had a review from Microsoft, a well-architected review on security, and what I think is very cool is that we scored on the question part 84% compliant, and on the advisory policy side we scored even 91% compliant. So even Microsoft was impressed with our setup. So, I think that's quite nice for us. We are also Haven compliant. That's very important in the local government area, because I think Haven is the thing, but Haven is 15 standards. So we are Haven compliant, but Haven is not Amsterdam compliant. We go much farther than Haven. We are also BBN2 compliant. That says something about the security of data which is used in the cluster, like personal traceable data. So we had to take that in care, and we had to take into account our current HubSpot model where the solution should land. And we want everything to be private, so our clusters are not publicly accessible. Default, if you deploy AKS, it's publicly accessible, but we use private endpoints for that to make it even more secure.
So basically we are not on the list that was shown yesterday. I'm going to take you with us with a lot of design decisions. I've tried to spread them in a sort of logical way, but looking to the platform, there were quite a lot, basically. So what we are trying to do is to get most out of Azure, basically. So authentication with Azure AD and that kind of stuff. And the most important one was, of course, the private functionality. So you can run AKS in public mode and also in private mode, meaning that you have to work with private endpoints, basically. And there all the fun was starting. Some functionalities weren't available at that time. For instance, it was the ACR, right? That was not very helpful. But also we had some other discussions. Besides of this big list, I want to highlight some of them. I tried to make them bold, but one of the key functionalities was we have to separate all our workloads, basically. Meaning that every workload has to be identified and must not see each other within the cluster. So when we started, when we first met, I said to the guys like, hey, do you know that there's one beautiful functionality coming available? And that is the agent pool concept. That is a functionality based on the fact that you can set in Kubernetes tains or sort of labels, and on that you can also set them in, how is that called again? Over availability zones. So you can basically select 3 of them, set them in an agent pool concept, and lay down a sort of Azure tag, and all the costs are also identified. Also, the traffic was separated completely. So that was a cool feature, and I think also the most important one of this list. Other components that we want to hit is the Nginx. So Azure offers in its subscriptions the possibility to use the AGIC, that's the Application Gateway Ingress Controller, the combination of the Application Gateway and the Ingress Controller combined. At the time that we have investigated, but also later this year in January, we still see it is in GA, but it's got a lot of issues. It's not reacting as it's supposed to be, and since we are facing 40 teams, we didn't want to look to that issue, facing the issues that they are explaining on GitHub, basically. So we chose Nginx, and in that way we can deliver very fast. One other element, auto-scaling is of course enabled on our side, and we're trying to use Azure Defender for Cloud as well. Looking to the automation, we are using, of course, the products that Microsoft is offering. So Azure DevOps is one of the tools that we are using. We also have taken a look to Cured. I don't know if it's familiar for everybody. Can I see some hands? That's familiar. A few of them, okay. So Cured is a Kubernetes reboot daemon agent. That's an agent basically working on each worker node, giving us the possibility to update our Linux operating systems, and you can add our schedule if you want to. For us, it's a weekly schedule, so if there are updates required for a reboot, it will do it by itself. Not meaning that all the nodes are coming together, but separately, of course. Another topic that we highlighted in To-Do is the automation of DNS and certificates. Most of you maybe are familiar with external DNS or Cert Manager. Those tools are mostly used in the automation. But we have some manual processes that's not allowing us to talk to the API systems yet. So this is coming, but maybe in the future. But for now, it's a manual process. Looking on the application side, so we have also taken a look to some applications. One of them was the application performance monitoring that we are filling in with application insights. Is it the answer for everything at the moment? We hope so. But we don't have any requirements yet to differentiate on this. So there are a lot of tools out there that's helping and performing in the application stack, but at the moment we don't have complaints yet in that way. Besides of that, we also use VM skill sets for creating our container images required for applications to run, of course. And that is also a lot of conversation about it because it's an IaaS solution. But at the current state, the only one that we can deliver. We also have taken a look to ACA, it's the Azure Container Apps, giving us the possibility maybe to create the self-hosted agents, a meaningful way to provision container images to build, but also to provision to our Azure environments. Looking to the security, of course, there are a lot of elements that we have taken into account. One of them, because we are using managed user agent pools, is that we have chosen user-managed identities, a way of authorization giving to an agent pool, and then later on in our slides to other resources that are specific for a workload team, but I will come back to that one. The vendor for cloud, I think that's obvious, of course, but one element that we are missing at the moment, and that's because it's not GA, of course, is the CI/CD scanning, so the possibility to scan our code, basically. It is coming, and we are excited to see, but for now we had to change on that direction to a third-party vendor. Other elements that we are using, of course, is the Azure policies. So in the Azure policies, Gatekeeper, that's a functionality for a lot of people maybe familiar, where you can set specific requirements on your cluster, on your total cluster, or specific namespace parts. Nowadays, it is built into the Azure policies, giving us the possibility to harden basically our clusters on the security side, on the cluster side, and also on the Kubernetes versions as well. The Kubernetes best practices also yesterday explained by you. And other elements that we are using is Calico policies. So Kubernetes offers us the possibility to go cloud native by itself, by Kubernetes policies. Those have the limitation that you can add them on namespace level. And Calico, one of the first CNI that is GA with Microsoft, gives us the possibility to not only limit it on namespace, but overhaul the cluster. So you can set your, basically your networking rules on the highest level as possible, meaning that you can make it closed unless, and then open with the specific firewall requirements of your needs. Looking to other elements, it's a bit too small, I do notice, so we have added a lot of links. A little bit of the baseline we just followed from Microsoft. So Microsoft is creating a lot of baselines nowadays, specific on the topics of ACR that we also required an AKS. And on that we have made a lot of lists to just peel them down. Looking to the end solution, what are we offering to our workload teams? The possibility, of course, to get their own agent pool. On that agent pool, we give them the possibility to differentiate based on the VM size. So if they need more CPU or memory, they can choose otherwise. In this picture, it's a DV4S v3. We also have given them a limit on the pod rate, so they are not over-provision their Kubernetes worker nodes. That is based on the VM size, because we are using the Azure CNI. The Azure CNI gives a lot of limits on that. And for now, most of the workloads do not go over the 50 pods. So looking to an /24 subnet, it should be sufficient. The network traffic we already hit on, and the Azure tag, of course. What does that mean for a workload team? So a workload team still provisions their own resources. That we do on purpose, because they are responsible for the database or a key vault for their certificates, for example, but also for their persistent storage. So we can deliver the full self-service functionality to them. And we are creating connectivity from our subscription, basically, based on an agent pool where the user-managed identity, where I just spoke about, can be authorized on those components what the workloads are basically creating. On that way, we can provision a lot of functionality out of the box. They get their own Azure DevOps, and on that we can create also the automation to the namespaces. And an element that we heard a lot based on namespaces. So we provision a namespace and the agent pool, and they can deliver all the applications they need.
So, roadmap. Of course, we don't have everything ready yet. We started last year. It's still work in progress. Some components are not available. So, workload identity. We are really waiting for Microsoft to have that GA. Really happy to implement it when it's there. The multi-listener support we already implemented at the moment. But that was one of the requests of our teams. Path-based routing, we also implemented that. Was also a request of the teams. Service mesh, we have not implemented service mesh yet because there's no requirement at the moment for service mesh. So why implement something which adds complexity if it's not needed? But as soon as as the requirements are there, we will implement it. GitOps is also on our list to implement somewhere this year.
Maybe you can switch shortly back. I forgot one element to add. On the left side, you see some components in the light blue, and those resources we have created for all the workloads, basically. And just to shortly tick them on, the application gateway, we have shared them basically on all the workloads that we have available. And also you see it's a Dutch word, beheer AVD, but what we mentioned is a sort of troubleshooting VM, so that they can do and see how their workloads basically are working.
Okay. So this we already. Future plans. We have a lot of other things. We are currently investigating, should we move to the Azure CNI and move away from the Azure CNI, leave the Azure CNI and move to the Calico CNI. We are doing a proof of concept with that. Container scanning, we just acquired a tool for that and are implementing that together with the vendor. CADA, also no requirements yet for it. Confidential VMs is something which we are looking into because next to BBN2 compliancy standards, we also know something that's BBN2 plus, that's more strict. So we are investigating if isolated nodes could be there, a solution for that. Some other of the things, AKS Edge is also one of the things which is there. If there's a requirement, we will implement it.
That one was released yesterday, so.
Lessons learned. I think one of our biggest lessons learned was that it's nice to deploy AKS, but it's not only deploying AKS, it's not ready, the product. You have to do a lot yourself. And what we found out is that our choice for running it private limits us in some of the options that are available. Some of the options for private are not available in GA, but for public they are available in GA. So we had some difficult discussions sometimes about that. How are we fixing that? Are we possible to, can we fix it? So a lot of things to look at. One of the other things is that the reducing of costs by sharing, that's a big win for us. Now we have some problem with convincing sometimes the teams that is really a win. That makes it sometimes more difficult, but we have evidence that it will save costs. So
and also the automation, right? I mean, we have provisioned everything with Bicep and all the automation tools. So it's not only AKS, but it is also the application gateway, the listeners, and all that kind of stuff.
Yeah, and I think the most important is that we'll never be ready. We always will have to need to innovate because there will always be new options on security or on Kubernetes. So we always have to innovate.
All right, that's it.
That's it. Questions?
Thank you very much, Dinan and Jürgen. I love that you guys have shared the wins, the learns, and the not so successful experiences. And totally, it's totally true that in container times, container years, 1 year is 20. So if you stop, you're staying behind. Do we have any questions for Dinan and Jürgen? Yes.
I couldn't stay away.
Bring it on.
I have one question out of curiosity. You say you are using private AKS clusters. How are you handling the build agents? Are all of your build agents in Azure DevOps self-hosted in some way, since you can't use the Microsoft-hosted agents?
Yeah. We use the self-hosted DevOps agents and the VM scale sets to solve those problems. Yeah.
Basically, we have two. One of them is specific for the image build process that we are doing on ISVMs in a skill set manner. So they are going up, and until their job is done, they are being destroyed. So every time they boot up, they get the installation script for the required tools. That's mostly one of them. The other one is the self-hosted agents that is currently in somehow a public form. So we have provisioned it in a public Kubernetes environment, strict, placed with a lot of network policies on that. So we can deliver basically only the needed requirements to go from public to private, to their subscriptions. And with Microsoft, we had last week, that's really fresh, we are taking to look to the ACA solution to see if they can offer it likewise, but then it's fully cloud native, unless they cannot deliver the isolation that we required.
Yeah.
Next question.
My question is related to cost management. So the moment you say shared AKS cluster, how do you do cost reporting saying this workload is consuming this much?
Yeah, we use tagging. We have a tag on the agent pool. So all the costs of the agent pool because of the tagging are visible, and we can show them to the workload. The shared costs are being divided over the workloads via a formula which is made by the FinOps team.
Okay, thanks.
We have space for one more question. Yes, we do.
I have a question regarding the controls that you put in place for Azure policy. How did you do the mapping for bio to the Azure policy, and do you have some best practices there how to do it? Because it could be a complex issue there.
Yeah. So we use the bio compliancy policy initiative from Microsoft. We use the SCF, and we have our own security risk team that extended the SCF and made sure that we had a translation to the Azure policies. And yeah, it was a lot of work. It's still a lot of work to keep it up to date, of course, because there are also changes in policies. We're constantly looking how to improve that and make it better.
A lot of remapping on all those requirements. So thank you. Good question.
Thank you very much, Dinan and Jürgen. It's always good to see consumers and their struggles and their successes. Please give it up for them. Now, one great thing is that everybody is trying to keep that door closed. Thank you. And one other great thing is that we are still on time, and we are going to have Floor, which at the moment she's very cold. She's going to be speaking at 3:30 with sustainable open source. One of those high energy people is always nice to have around. So please take your break, 30 minutes, come back with us. Sorry, folks. Can I ask something a little bit unusual? Can I ask you all? We have a little bit of an empty room, and can we move a little bit all forward? Yeah? How about that? Do you feel like it?
We're here.
Yeah. Then we all get warmer.
Yeah. Oh. Fun.
Okay, I would say we get started. We are getting towards the end. We still have few to go, a few talks to go, and we have a keynote from a mysterious speaker. Beautiful. We have sustainable open source from Floor, which is a community. No, it's not. It's not. She's not.
Well,
she's not
yes,
a community. She's not community. I'm not going to tell you what she does. It's a super long title, and I fell asleep midway. So, Floor, please join me. Give it up for her.
But I appreciate you for trying. Yeah, you did try. Hi, everyone. Yes, it's nice that you come sit a little bit closer so I feel a little bit of your warmth because I've been freezing in this room. I don't know about you. All right, so sustainable open source. In this modern world, we rely on a lot of components for all of our stuff to work and for it to continue to work. And I know you know this to be true, but I still want to elaborate a little bit because I'm up here now and I'm giving a talk. So if that was the statement, it would have been a really, really short talk. So there's been a 2022 study by OSRA together with the Synopsys group, and it came back that 97% of 2,400 plus audited code bases contain open source software. Maybe you're not surprised. It is a large number, though. And some of the sort of like subgroups, sub-industries that they were investigating even sometimes contained up to 99% of open source in their commercial code base. So large enterprises and all kinds of companies rely on libraries that are sometimes maintained only by a single individual in their free time, and that creates potentially some attack surface, right? And sometimes organizations will restrict their the way that you can use their software, or end-of-life versions that are actually open source, and that's all kinds of difficult to deal with. And so in the next 30-ish minutes, I'll get cues whenever I run over time, I want to talk a little bit about the viability and the sustainability of open source software so that we can all continue to enjoy the benefits that it brings. So who am I? My name is Floor. My full title is on there, so now you, now you know. I do enjoy my chickens a lot, so hence this picture that was taken by this wonderful gentleman here in the front. So if you ever need a new profile picture, you now know how to go to, who to go to. I'm a staff community program manager at Ivan. I just switched jobs actually last week, so don't ask me what I do because I don't really know yet. I was at Ivan before, but I just switched teams. Ivan is a database as a service company, so we have a couple of open source data tools that we manage and that we offer, and we also contribute to these upstream projects like Postgres and Kafka as well. Previously, I was at Microsoft, and I was at Grafana Labs. I'm part of DevOps Days core team. I organize DevOps Days, or co-organize DevOps Days Amsterdam and DevOps Days Eindhoven. I'm a Microsoft MVP. And I also organize a lot of meetups. Contributing.today is one of them that sort of started around pandemic time and was basically just conversations with a lot of open source maintainers and anyway, like people in the open source space. Learned a ton from those meetups too. And what I've learned from those meetups, I gave a talk at FOSDEM earlier this year. So if you want to check that out, how you can sort of spot healthy open source communities, then definitely go to the FOSDEM website. All right, what are we going to talk about today? We're going to talk about some issues that are prevalent in open source these days. And one of those is project relicensing their software in order to avoid free riding from, for instance, cloud providers, more on that later, or to avoid that bad people use people's software to do more bad, or to alleviate some responsibility. Also recently, relicensing because they couldn't secure funding, and it was sort of like posed as a threat. If you don't give us funding, then we need to relicense in order to make money out of this thing. I hear a little bit of feedback here. Is that okay? Is that normal? I hope that nobody in the audience hears this. And another problem is this, this idea of the project that is maintained by a single individual in Nebraska. I'm sure you've all seen this XKCD comic that is absolutely like wonderful, and you'll see it around a lot. It is more prevalent than you would think or that you would want it to be. So while curl is successfully maintained by Daniel Stenberg mostly in his lonesome, for every curl there is a log4j, right? That is actually, yeah, not great. And with every NPM library you bring in a whole host of NPM libraries and all their transitive licenses, for instance, that you need to keep track of, because that's creating an attack surface. And there is a lack of resources that maintainers can tap into in order for them to really spend the time on their project that, you know, like the uses by bigger companies or enterprises would really warrant them to spend on it. And also maintainers can sometimes make very rash decisions. They're much like you and me in that way, right? Like sometimes they will want to protest something, or they will want to have their opinions heard, and sometimes they will use their work in order for people to actually listen to that. Are these the only issues that are plaguing open source? Definitely not, but again, I only have 30 minutes, and I would love to talk to you about, you know, like diversity, equity, and inclusion in open source, or lack thereof. But again, like let's focus on these two topics, and then maybe in the hallway or the barbecue we can talk about all the other things. So in the recent years, we've seen an increase of kind of open source licenses, and I want to have a look at a couple of them. So for instance, the Commons Clause that aims to restrict commercial free riding on open source code, especially cloud service providers who don't give back to open source projects. And the Commons Clause actually conflicts with the FSD, the free software definition, which claims the right to use software for any purpose, and the open source definition, the OSD, in that the license shall not restrict any party from selling or giving away the software. And there is a bunch of sort of ambiguous wording in that license, and I don't want to give you a license lecture because that's not great. But for instance, it says that the value is derived entirely or substantially, but it doesn't really explain what substantially even means. So like beyond what would that actually come into play? And MongoDB used that license for a while, as that did Redis Labs. Redis Labs actually combined it with the Apache, which is a dual license, and that brings in a whole host of other problems, by the way, because when does what work? And Mongo then switched to the SSPL, which is kind of like the GPL license, but with more restrictions, and it's not approved by the Open Source Initiative. If you're not aware, Open Source Initiatives are initiative is the stewards of the open source definition, so the OSD. So there is a couple of licenses that become prevalent sort of the last recent years that are not actually approved by or like in line with the open source definition. Redis Source Available is a recent license that came into play. Elastic 2.0 is the license that recently came into play, and I will focus on a little bit later. A lot of services create their own licenses, which is even more difficult to sort of keep track of. There is an interesting one that is the Confluent Community License, for instance, which says that you can use modified distribute unless that competes with Confluent's business. But of course, like Confluent's business could change, right? You don't know. It could be like that could be a slippery slope. So if they change what their business is like, then using something. Using their software could then suddenly become illegal. So difficult stuff, deserves a whole study of its own. And most people that work in open source or work with open source just want to make use of open source software and not be reading licenses all the time. Also, projects just switch license, so how to deal with that? What I did at a conference not too long ago is that whenever a speaker takes a sip of water, the people in the audience applaud because it's actually really difficult to remember. Thank you. All right, and then there's also, besides those kind of new licenses, there's also another type of licenses that are, for instance, the ethical licenses. So I don't know if anyone has heard of ethical source or the organization for ethical source, but for instance, there's a couple of ethical licenses as well, like the Hippocratic license, that is a license that prohibits use of software in violation of internationally recognized human rights, or the ML5, which makes an explicit connection between a license and a project's code of conduct. So the ethical source working group says that over the past 20 years, open source has, of course, proliferated, right? Like it's everywhere, but the developers in open source don't actually have any course of action to make sure that their work isn't used for bad causes. And feel like the open source definition should move with the times and figure out a way for open source developers to still keep offering all of their stuff in an open source manner, but have some sort of way to sort of recourse whenever a bad actor is using their software. If you're interested in learning more about ethical source in particular, please check out ethicalsource.dev because I won't go into it much more. All right, and I know what you're thinking, like open source isn't about licenses, right? Like it's about the community and working together and openness and freedom and all of that beautiful stuff. And licenses should just be sort of like an instrument to make sure that people use software in the right ways. But I do think that this whole discussion around the cloud restricted licenses was a really interesting and an important one to have with the community. It's just not a way to save open source. First, because it's not compliant mostly with the open source definition, but also it takes the code private, and that can really hurt a community, right? So changing your software because you can't use a particular part of code anymore, that's really, really difficult. And I'm not entirely sure, or we're not entirely sure if that's something that really was necessary for the economic sustainability of some of these projects, right? Like Mongo and Elastic were really big companies in their own right. So did they really need this? They felt like, yes, they felt used by, for instance, AWS. And even taking enforceability out of the picture, because it's actually really, really hard to sue and win in cases of copyrights or patents infringement. Changing to a more restrictive license might cause companies and community members to stay away from your projects. And that's actually really detrimental to a community and ecosystem. So they do provide free writing, yes, but that comes with its own set of problems too. All right. So let's look at some examples of projects changing their license. Quite recently, that was Lightband that changed Aka's license from Apache 2.0 to the BSL version 1.1, which is a business source license, and that would have started with, or did start in October with Aka version 2.7, which, I mean, side rant, if you change your license, then do it in a major version because you're actually breaking your API. So 2.7 doesn't indicate like something actually really, really changed. But okay. And with any such change, there's always talk of a fork, right? And then people that advocate for that fork to then take a sort of copyleft or infectious license to make sure that whatever changes are made to the fork is not something that the original project can just grab and benefit from, because they changed their license, so they shouldn't benefit from any community work anymore. And while it's understandable that that sentiment sort of like arises, it is sort of the question of how effective this will be, and if hurting our fellow devs is actually really what we want. Like, they didn't, that they likely didn't make this decision. So it might be really misdirected anger. All right, so there was talk of a fork, and then there actually is a fork. So Apache Pecco is the fork that is now incubated by the Apache Foundation, and thus with the Apache 2.0 license. And actually, some people at the Open Source Program Office at Ivan are very much involved in this project, but shameless plug. Anyway, another project that changed their license is Elastic. I don't know who was affected by this, but this was a blow to the community. This was super hard, yeah. So and several players then eventually also decided to drive a fork forward. So if you're familiar, OpenSearch is the open source alternative to Elasticsearch. That also, disclaimer, Ivan is very much involved in, but so is AWS. So much for like cloud providers that don't give back to the community. Yes, it's difficult because Elastic actually changed because of AWS, but they are also invested in creating an alternative that continues to be open source. And AWS is actually like really driving that forward as one of the main players, and that's again something that is really, really difficult. You'll see a lot of open source projects that almost have a single vendor behind them. For instance, Apache Kafka. Kafka is also in the Ivan portfolio, or rather the decision of what makes it into the Kafka project is largely in Confluent's hands. And that issue of the single vendor, you'll see a lot. Databricks has a stronghold on Sparks. Google and Beam are a very similar story too. Then Grafana Labs changed licenses to AGPL version 3 for Grafana and Loki and Tempo. And Google warns against this using the AGPL, saying that the risks heavily outweigh the benefits. And then the Cloud Native Computing Foundation, of course, in response to the license change of third-party dependencies to the AGPL, encourages everyone to either switch to an alternative component, freeze the component to the version prior to the license change, or seek an exception, like from the governing board. So needless to say, they're not big fans. If you install, for instance, Electron, you install 87 packages, and that means 87 license dependencies. And every single package is likely to have their own dependencies as well, and therefore even more licenses that you need to comply with. As you can imagine, license management can get really, really, really complicated. And when done manually, can absolutely create technical debt. So there are about like 300 plus different open source licenses, and that list is ever growing. However, the good news is that about 20 licenses account for like 80% of open source commonly used in enterprises. So if you create a deny and allow list of those type of licenses together with a scanning tool, that would already provide you with a pretty good starting point in managing your license exposure. And of course, there is license auditing tools as well that can send you notifications after projects change their license. But it's very reactive, right? Like you would rather know in advance whenever a project is in danger of maybe potentially changing their license, or the ways you can use it. I mentioned before that license litigation is actually really, really hard. True, but it does happen. And you might end up needing to change your software in order to comply with the license of tools that you're using. And that's not great. That's a lot of work. And also you might actually get a lot of bad press for not being able to comply with a license, and especially in very sensitive industries, that's difficult for a company. Did you already show me some time, or am I still going? I'm still good. Okay, I'm doing great. Okay, reference time. Dotan Horowitz, who works for Logs.io, actually gave a really, really interesting talk about when Elastic changed their license and how they dealt with that change. So definitely check out their talk. Making friends here. Okay, I want to switch gears a little bit and talk about maintainer. Now you show me time, okay. About maintainers and about maintainer resources. And there was a tight-lipped survey in 2021 that came back that 46% of maintainers are not paid at all. No big surprises there. Only 26% earn more than $1,000 per year, which I don't know what your mortgages look like, but that doesn't get you very far. And almost half of the responders also said that they have considered to quit, or they have either quit or considered to quit over, and list that lack of financial compensation as one of the prime motivators for that. So open source libraries allow all of us to move faster, but if they're poorly maintained and they're not healthy, they can become a single point of failure. I feel like I'm like preaching to the choir, but who knows. So I mentioned before that contributing today is a meetup that I ran, and one of our guests was Henry Zeus, of course, the Babel maintainer, and his story was really, really interesting because he mentioned at one point that people around him got upset that he would spend a lot of time fundraising for the project just to make sure to keep it funded, right? So he spends time talking on podcasts and to try and get donations. And they were like, but you should work on the project. Why are you not committing more code? Like, what is this? You're a maintainer. And he really struggles with this too, because he feels almost like guilty whenever he's doing any kind of like marketing or promotion for the project. And so we've come to this weird place where we think that whenever we're donating, like we have a FOSS fund, we donate 10K to a project. Yes, but you know, y'all are software people. What do you earn annually? You don't need to say it. We can talk about it later. We can talk about it later. But the 10,000 is nothing, and especially when your project is not necessarily set up to kind of sort of distribute that kind of money to all of your contributors. Like, it only introduces a lot of complexities. It doesn't really help a lot. And I think it's interesting that while a company would love to have some runway in order to do their job, when you have an open source project, that might actually send the wrong signal, because you didn't need the money. You developed this project before without getting money. So now, what do you need this for? And it sort of ties into this whole toxic notion that open source shouldn't be about money, right? Like, you shouldn't be paid ever, because only when you are in your mom's basement, deprived of sunlight, then you're like this true unspoiled hacker. But it's ridiculous. It really is ridiculous. Anyway, check out this episode because it was really, really interesting. Another reference time. Bartolome did a wonderful talk at State of Open Con earlier this month and talked about lessons learned developing and maintaining the Thanos project, and sort of like, yeah, what as a maintainer, if he could go back to like baby Thanos maintainer, what could he tell them? And if you're anyway there, on the YouTubes of State of OpenCon, you can also check out Dawn's talk about open source strategies. It was a really, really good one too. All right, so some examples, and I will rush to some of them, of open source projects that you know, sort of like went bad and then got all of us in a sort of a kerfuffle. One of them was, for instance, LeftPad. Do you all remember what happened to LeftPad, sort of, kind of? So many hands. All right, so LeftPad did almost nothing, no? It sort of like padded out the left-hand side of strings with zeros and spaces, but still thousands of projects relied on it, including also Babel from Henry. And when the maintainer removed the project from NPM out of spite, these applications and like widely used bits of open source infrastructure were unable to obtain the dependency and then fell over. The maintainer was really disgruntled. Some project from Kik, if you know, used the same sort of name, and they wanted to claim that namespace on NPM, and so lawyers went after NPM's admins claiming brand infringement, and instead of NPM standing behind this maintainer, who had, by the way, 200 other projects hosted on NPM, they decided to pull the project, and he was very, very angry. There's many such examples. Maybe you've heard of Seth Vargo, and when he discovered that some of the things that he had developed for Chef were then used by ICE, the customs and integrations in the US, pulled his code. And when there was a whole upheaval over that, he was like, well, it's actually in my sort of will that if I were to die, tomorrow, those libraries would also be pulled from the internet, so better be ready. Colors and Faker.js, anyone familiar with what happened for those? It's like, yes. Right, very popular projects, very, very popular. To illustrate, Colors has scored more than 3.3 billion downloads throughout its lifetime. And has over 19,000 projects that depend on it. Both projects were hijacked by the maintainer, by the way. Later, it became clear that it was likely because the developer had expressed an intention already of no longer supporting big companies with his free work, and that businesses should actually either fork the projects or pay him, and I quote, a six-figure salary, which fair enough. Like, we all rely on these projects, so like, why do we think we can get away with it? Another one is Node IPC. I'm running low on time, so I'm gonna quickly go through this. But Node IPC, the developer behind this, sabotaged some versions of the library in protest. So there's protestware in protest of the ongoing war in Ukraine. And so definitely users in specifically Russia and Belarus were affected by this change. Last week, Core.js, I don't know if you've seen this, definitely have a read. Oh my God, what a shit show. I didn't want to swear on stage, did I? Sure. I didn't swear. We're in Europe, we can swear on stage. Okay. Generally, open source is part of our infrastructure, in our products, and our tooling. And for this reason, we need to care about it as if they were our own projects. No company will leave any of their critical infrastructure or in-house developed tech stack unmaintained. So why are we willing to do so for the ones that are open source? Log4j, don't need to tell you about that. So sometimes we think that open source is inherently secure. The code is out in the open. So if anything is broken, right, like people will see it and they will mitigate that, right? Like, but then how do you explain all of these things? And how do you explain Log4j and Heartbleed? So that many eyes argument is very, very shaky because it needs the right people to look in the right places. And I feel like most developers come to open source for solutions and not for more problems. A lot of stuff to back that up. But I want to go quickly through some of the things that we can actually do to make sure that open source is sustainable. So making sure, you all have a place in making sure that open source is sustainable. One of those things is to invest your time and to invest your money, but only when it's applicable. Sometimes projects have enough of your pull requests, all right? Enough already. But they do need help triaging issues or with code reviews. So spend time where project might really need your time, and spend money whenever they can accept, for instance, through GitHub sponsors, but only when it's applicable again. Make sure that you yourself are an excellent open source project. Maybe if you're a company, put some maintainers on the payroll and make sure that they don't have to comply to the same, or they're not tracked by the same OKRs as the rest of your engineering department, because open source moves at a different timeline. So please measure them accordingly as well. Join a foundation maybe. And join forces with other organizations. There are other organizations that rely on the same libraries than you do, so make sure that you can maintain them together and they're not dependent on just one single vendor. And when you participate in open source, please look at the principles of authentic participation. Don't think that you can just fork a project and maintain a bunch of mirrors of all the projects that you rely on, because also, first of all, congratulations, you're now a maintainer of a lot of open source projects, and people will come to you with all of their issues. You don't want that. But also, open source projects are, vulnerabilities get fixed too, and sometimes vulnerabilities are in a code for a really, really long time, weeks, months, years. And you want to benefit from all of those patches too. Good. Totally in time, right?
You were great. You were great. Thank you, Floor. I'm
going to keep the water.
You can keep the water, but leave the laptop. Please
give
it up for Floor again. And I must say, you were perfectly on time when you mentioned investing in open source, because I saw the guys from Rabobank coming in. Hello.
Oh, actually, I gave a very similar talk to Rabobank once, so maybe they will remember me.
Fantastic. We have time for 2 questions, if you're okay, Floor? Do we have any questions? Yes, we do.
Hey, I am becoming increasingly worried about packages and maintainers' right to die, right? Like my right to no longer maintain something. And I reached out to the Colors and Fakers maintainer, and yeah, they're super extreme, but also I was like, hey, thank you so much.
Yeah.
That was the kind of action that we need to take. Totally illegal for Microsoft to then go and take on ownership of that repository, because the license plainly states the roles and responsibilities of the end user, right?
Yep.
Not appropriate. Right now, there's a bunch of maintainers that don't want to be in corporate open source.
Yep.
And those are the ones that are mostly at risk. So can we find alternative models to engaging with open source in the wild that doesn't require them to work at Google?
No, yeah, because they shouldn't need to work at Google if they don't want to work at Google, 100%. I feel like we have way too little avenues for maintainers that don't want to be employed to be able to have a consistent income, and that's absolutely a problem, and that's something that we need to talk about. And if that's funding through some other way, or helping them to actually be able to get funding, because that's also this is complicated, right? Like it's almost like you're running a business. What? So yeah, there needs to be more work there, and there's way too little work there. It's pockets of money here and there, and you end up spending too much time, like Henry, like just to get those pockets of money consistently to make sure that your project can continue. Yeah, so 100% agree. I saw one more hand up, but yeah.
Yes?
First of all, like your shoes.
Thank you. I love them too.
My question is, if you look at open source maintainers or software developers, I think there's also a sort of social issue, because if you have to maintain an open source project, you also have to sort of lead a community. And I think in that point of view, the best example is Linus Torvalds being unable to communicate with the other kernel developers in a way that people feel appreciated for the work they do. And I think that's also one of the things that might help those projects to prosper if we could invest a bit more in that aspect.
Yeah, for me it would be super interesting to see if we can find some people to get more involved in open source that have some of those skills that come into play whenever you want to start running a community. So more attention for the non-code contributions, but maybe for building a community and doing technical documentation really well, and marketing. And there's so many roles to play in open source, and that go beyond code 100%. And you can't be everything to everyone as the single maintainer. Like takes a lot of time. That's why companies have all of these different roles, right? Like, yeah. I wish that that would be more appreciated. Yeah, but then you look at GitHub and you only see the green little, blocks for code changes, and there should be green blocks for all kinds of things. Yeah.
Thank you, Floor.
Thank you.
Was great. Definitely contribute to open source. And I do have a couple of questions about the chickens, but I'll leave that for later.
We can talk about that later.
Yes. Thank you.
I'm just glad that there's no chickens killed for the barbecue today. That's good.
No. There were a lot of veggies killed, though.
Yeah. Okay. That's fine.
Thank you. Okay, guys. We are going to have our next talk in 10 minutes. So some of you may just have come in. And you want to stay here. The others, please stay here. So we're going to be together again in 10 minutes. Now it's nice when you see 4 guys behind a laptop screen, you know that something happened.
Yeah. You are Shirley. What is your role? I'm a site reliability engineer.
Good afternoon. That was entirely planned. We wanted a fuller room. Now we have it. We had no problems whatsoever. We have Sherwin from Rabobank, product owner for cloud, as well as SRE, kind of jack of all trades, I suppose.
Yeah.
Give it up for Sherwin, please.
Thank you. Thank you. All right. Thank you all for joining this last Friday, last talk. I hope you had a great day today. I saw some really interesting talks as well. Some of those will tie into what I'm going to show you today. So, I want to talk about Kubernetes in the enterprise. What does it mean, Kubernetes in the enterprise? Well, first of all, let's talk about what is the enterprise. So, for me, I'm like a technologist at heart. So what I thought the enterprise is just like, dusty old people sitting at a cubicle farm, something like this, right? Who thinks about, when you see an enterprise, who thinks about this? Show of hands, yeah, that's exactly what I thought, right? But when I got older and I saw what people actually do and the processes, like the enterprise is much more than just a couple of people or like a bunch of people in a room having meetings. For me, an enterprise is a cohesive ecosystem that creates value for the people that work there and also the people outside of the enterprise where the enterprise does services for. It's a highly advanced technological machine where people work together. They have different roles, they have different outlooks, different skills, and together they create an amazing product for their customers. And that is what I think an enterprise is. So for me now, an enterprise doesn't look like this, it looks like more like this. This is an enterprise. It's an ecosystem. If people don't work together, what happens to the enterprise? It falls apart or it crashes. You know what happens with this thing. And it's a fun story because when I started my career a decade ago, the people that were there, the technologist and the lead developer, he called me Georgie LaForge. And I didn't know what Georgie LaForge was. I wasn't a Star Trek fan. But he commended me that I can come up with like very good technological solutions in a short amount of time. And now that I'm like looking at this whole endeavor, what I've been doing and stuff like that, I feel like, hey, Georgie LaForge. This guy. Kind of look like him if you look at it. Thank you. But we also have other people, of course, different roles. This is the frontline risk that we have at Rabobank. These are the security guys. They're very strict, they're very to the point, but they are fair. Because understand, with an enterprise, there's a lot of problems that can happen, and you don't want to basically bring the enterprise down. And we also have another role. These are the architects. And this is what I see. This Geert-Jan, if you have seen Geert-Jan, he's right there. Kind of looks like him too. But yeah, he really, so he really makes sure that we do the right thing. Because he understands not only low level, but also what happens on top. He speaks with management and also the people above that, which is very important to make sure the enterprise keeps on flying around. All right, a little bit about myself. So yeah, I'm Sharon Noitmeer. I'm an SRE at heart. I've been doing this, as I said, for more than a decade now. I worked at some notable companies like Spotify back in 2013. I'm originally from the Netherlands, but I'm born in Suriname. So I worked in Sweden, then I went to London, worked for Palantir Technologies. I started my own company there as well. Did a lot of cool things, all the way from bare metal, putting it in the racks and making sure that the fiber channel is working, the Cisco switches are working, everything is redundant, everything is working fine and dandy, and the monitoring system is in place, and backups as well. And I just basically grew from there to the SRE that I am right now. I write a lot of automation, I write a lot of Go, I do software engineering, but mostly on the architecture. And now as well with Rabo, we're at the forefront to transfer to the cloud, and there I help the team, our team, Team Vikings, together with also TCS, to make sure that we get the application that is now working on-premise, and we want to basically get the application to the cloud. And TCS has helped a lot there too. And why am I showing this particular picture? So you can see this commit has been made by me in August 2018. This is the first time I actually wanted to deploy Kubernetes in a bank. The bank was Network International. It's a bank in Dubai. And I was there and basically wanted to first get me to install Kubernetes on-premise. I thought, okay, it's going to be a difficult ask because they have a lot of policies there, a lot of things that you can do. You cannot just pull images from Docker Hub with your Bitcoin miners in there and stuff like that. It's kind of difficult. But within a week, with having also first-line risk there on the phone, I basically installed Kubernetes in a week on-premise in Network International in a bank. That was the first time. That was in 2018, the beginning of 2018. And when I did that, I'm like, yes, let's use the cluster. And then he said, no, we have to do this in the cloud. So here we are. We were using AKS engine, and actually it was not AKS engine. It was called ACS engine. AKS really wasn't generally available at that time. So what Microsoft did is they open sourced the engine that basically installs Kubernetes for you on Azure, but it was not ready for a bank. And why was it not ready for a bank? Yeah, you can see here right now, there's a nil pointer. When you want to use hardened images, and that's what you want to use when you're in a bank, you want to make sure that you're secure, you want to use your own images. But if you use your own images and you install Kubernetes, what happens? It crashes. Why? Because you didn't check your pointers. So I needed to make sure that that didn't happen. So I made this commit, and the same day it got merged, and we could actually continue to deploy Kubernetes in the bank. which is great. And this is what I call pushing the envelope, because basically, AKS was not ready for the financial industry at that point in time without this particular single line of code. All right, thank you. So, the enterprise is not only, Kubernetes into enterprise is not only a technological challenge, it's first and foremost a organizational challenge. You cannot just go in and then install a cluster, have a public load balancer exposed, all your S3 buckets exposed, and then think you can run a bank like that. Before you know it, you're hacked, and then you have to pay some, like, I don't know, some ransomware money to make sure that you get your data back. So to make sure that we don't make silly mistakes, because like the #1 mistake is like open S3 buckets, and for Kubernetes, I thought, I heard a different talk not so long ago. There were like 1 million open API endpoints in the wild. Isn't that crazy? So we don't want that to happen at the Rabobank. So what do we have? We have a bunch of enterprise roles, people, groups. We have the Cloud Competency Center, the CCC, an incredible team at the Rabobank. What they do is they help you to make sure that you make the right choices inside of your AWS account. So you don't open up like the API endpoint for everyone. But also, if you do something that is silly, there are automated tools to make sure that that silliness won't actually become a problem, because if you create a public load balancer, they make sure that it automatically gets deleted. I already talked a little bit about first-line risk. It's very important, the first-line risk. Make sure that all the policies are also in place, so we don't expose the Kubernetes cluster or actually anything in the AWS environment or any actual environment. Rabobank is multi-cloud. So we make sure that no problems happen, or the risk is at least mitigated, or we accept certain types of risks. We have identity and access management. We have to make sure that we have all the accounts, people who can access the cluster, who can do the certain things. You have to make sure that like a group of people can access the cluster. We have people from TCS right here. They can also access the cluster in a particular way. There's a whole group of people that make sure that you get the right identity and access. We have the infrastructure architect, the solution architect, the business architect, and much more. Those are all people making sure that the enterprise stays afloat. All right, the placement in the investment stack. So what are we actually doing, right? Why do we have Kubernetes? As I mentioned before, we want to make sure that the investments back office, the blue circle, the blue square right there, that is basically what we want to run. That is the whole back office. If you want to do, for example, investment portfolios, ordering corporate actions, payments, these are all things that are being handled by the back office. There are connections to Euronext. Some of y'all probably know what Euronext is. This is where you can place your orders and hope for execution. And this needs to now run on top of Kubernetes. We had it on-premise before. When you go in with Rabo and you have like your phone and you want to create or you want to start or open an investment account, this is what you see. You go through the whole stack, and in the end, you come with like the complex workloads where the investment back office runs on Kubernetes, and the red part, this is where I come in, or we come in as a team to make sure that that is good and that the functional teams can consume that. All right, next, the application architecture. Well, this is something, looks very complicated. I'm not going to go into details, but just to give you a view of like how complex this is. There you see all the connections from the external side come in, and all kinds of things are being hit and being talked. Like we run now with like 40 transactions per second, but you can imagine any one transaction can multiply into like 5 or even 10 times as much, because it propagates across the systems, and different systems need to do different things so the client can be helped. Some metrics. So we have 19 systems integrated. We have 44 APIs provided to the front-end applications, 8 different communication protocols, and 70 different types of batch processing. And that's all in a nutshell what you saw in the picture before. Now, some fine-grained components. I'm myself particularly interested in the Kubernetes part, and what are you running? So these are all the components that you're running. This is a DevOps It's the DevOps squad that we have. But so basically, we have Splunk, we have Dynatrace, Amazon CloudWatch. That's the monitoring side. To deploy Kubernetes, we use Terraform, and Customize. That's basically the building blocks to deploy Kubernetes on. So Terraform to deploy Kubernetes, and then we use Customize to do the rest. And inside of the cluster, of course, we have Flux. Where's Flux on our list right there? Right there. So we use Flux CD, so we use GitOps to make sure that all the credentials stay inside the cluster and the state is reconciled with the Git repository and also the Docker registries. All right, a little bit more metrics. So we have 3 accounts and 5 environments. Well, we have more accounts, but 3 active accounts at this point of time and 5 environments. How can it be? Because normally I would do 1 account per environment, but it's a different setup that we have here, because if you create an account, you have to go through the whole process. There's a lot of people, as I said before, involved to make sure that we do the right thing. And it's much easier if you want to create a functional environment that you can do that on top of the Kubernetes cluster, because you can use Kubernetes to run different types of workloads. So why not just have different node pools that you can use that are specifically used for a particular functional environment. So we have performance tests, we have acceptance environments, we have all kinds of other environments for the staging account. We have the development account, of course. This is where the initial CI/CD process starts from the Rabo side, and we have also production. Right now, it's just one environment, production, but it will be split in multiple environments. You see also the amount of nodes that we're using, and staging has the most nodes, 51 nodes, 720 cores, and almost 3 terabytes of memory. So yeah, it's a pretty expensive, but yeah, we are in the enterprise, and so the operational expense might be a little bit higher, but the capital expense is much lower because you don't have to use any on-premise systems anymore. As I mentioned before, we do GitOps. This animated GIF, so immediately you see what happens. Flux is running inside a cluster. We have a developer. The developer changes the Git repository, and what happens, Flux makes sure that the system is reconciled, but we also have Docker images. And if there's a new Docker image that gets pushed to the registry, Flux will automatically deploy that image to the Kubernetes cluster. All right. So we are now in the process of going to the cloud. It has not been an easy process. It's actually a very complicated process. There's a lot of things that we've touched. There's a lot of things, a lot of communication that we need to have. There's also technological challenges. What I see in a lot of companies is what they do usually is they make their own bespoke solution on top of Kubernetes. We already have a lot of YAML files, and what they then do is they create a template system to make sure that you don't repeat yourself. And I think that is not really the right solution to go. I know Helm internally use templates, but otherwise, I wouldn't use any templating system to do YAML. I wouldn't make anything bespoke. So what would we do different now? First of all, I would standardize as much as possible. So there are multiple groups of people in the Rabobank that are using Kubernetes. At least 2 of them are using Customize. 1 of them has a bespoke solution. And as we have seen in the talk before, you want to remove your unicorns. You want to move fast. You don't want to have 50 planes that you can make in a year. You want to have 50,000, right? How do you achieve that? How do you get agility? Is by standardizing. So maybe not everyone would like that. You have some rockstar engineers. They want to do their own thing. And of course, I understand that's also very possible. Like everyone wants to do that. But for an enterprise, that just doesn't scale. So standardize. The other thing that I find very important to do is involve enterprise expertise earlier. We've made some decision. So inside of the cluster, we're also using Argo. Argo is a big part of our CI/CD system, and it's a tremendous tool. It works very well. It works very fast. You can do a lot of things with that. It's a versatile tool. But inside of Rabobank, we also use Azure DevOps. And the pipelines are compliant. There are security checks. And what's going to happen now, if you're using a tool like Argo, it needs to go to a process to accept that tool. It's a cloud risk assessment that you need to do before you're going to run a tool inside of the cluster. Because any tool that you get from Docker Hub or anywhere else could be compromised or has maybe not the right security posture. You want to verify that first before you're going to roll that out. So these decisions you need to make not lightly. And let's see, so the next one is start processes earlier. So if you use something, a tool that is not necessarily Rabo endorsed like Argo, what you can do is start the process early. If you want to properly risk assess that tool, you have to make sure that you go through the proper channels. And it can take 3 months, yes. There's a lot of people that need to sign off on things. People need to actually check. People will check the code. People will do pen testing. People look at even the maturity of the project and the impact of what you're doing there. And another thing that's very important is the consideration for day 2 operations. What is day 2 operations? You have first day operations. That's basically when you install the cluster, when you install all the tools, when you just start doing things. But you have to maintain the cluster. You have to have updates. You have to install new tools. You have to make sure that you are with the right API versions, etc. So the tools that you pick right now, they only don't exist now, but they also exist for your predecessor. So you have to make sure that you also take them into account. Let's see. So there are a bunch of key takeaways. And first of all, keep it simple. See, a lot of people wanted to make a lot of interesting things, but I like boring now. I'm now like 36 years old. Some people think it's not that old, but for me, I've been in this industry for too long, and I don't think like new and shiny it doesn't excite me as much as actual having some stability, making sure that we can continue the business, even though if someone can't fix your tool and someone is very good at the tool and it's not there, you should still be able to fix that. Don't temple YAML. I can't say that enough. Don't create your own bespoke systems. And for Kubernetes, it's very important to extend your base infrastructure configuration. So don't template it, extend it, and use customize. And I also want to show you a little bit about customize. Let's see. Oh, now I have to mirror my screen, right? Let's see if I can do that. Hey. What if I stop this presentation for a second? Or can I just mirror the screen? I'll just mirror the screen. So who of y'all is familiar with Customize? Nice, very nice. Who isn't? Okay. There's a lot of people not raising their hands, so I don't know. Who knows what is Customize? I will shortly explain that. Customize is a tool that basically allows you to patch your YAML. And patch, so you have a base YAML, and you can basically say, well, I want to take this base YAML, but I want to extend it with a little bit of this, with this snippet. Thank you. Let's see.
Can I help with extending?
What's that?
Can I help with mirroring the screen?
I think you can. Wait a second. Extend, no, I have it here. Mirror for built-in display. There we go. There we go. Hey, if you want to check it out, because I don't know what this thing is doing. Yeah, come over.
Wait, if you go to displays.
Oh, displays? Where's displays?
Yeah, this one.
Yeah.
It should be.
Decimator? Extended display.
And then you can.
Mirror for display, yes.
Yeah.
Yes?
Right?
Wait a sec.
Up here now.
Oh, when you go there, then it doesn't do that. Okay, let me just fix it real quick by doing this.
Yeah, you got it?
Wait a sec.
Yeah.
Because it does this again. Main display.
It It might be PowerPoint messing it up.
What's that?
It might be PowerPoint messing it up.
Yeah, PowerPoint's messing this up right now.
Yeah. Maybe stop the presentation and then.
I have to check it here now.
Yeah.
Stop.
Was this?
Oh, but this is up here.
Yeah, I know. There we go.
Yeah, that's it.
Thank you.
No worries.
All right. So very simple. This is, so Flux, if you have to first install Flux, and we have installed Flux. I think this is visible for everyone. Let me just make sure that it's a little bit bigger. So this basically is the basic Flux configuration that you can use to say, okay, I want to already configure the Git repository, and this is what you do in dev. We have a directory called K8s, short for Kubernetes, clusters, dev. So that happens, and so if you see here already, we have here the directory called K8s base. This is where all the YAML is in, resides in. And then we have the K8s directory, right? Clusters, and then we have dev, just like you see here in the path, right? And then if you look at, for example, all the applications that are installed, I'm now actually showing RFTM. RFTM it's not RTFM, it's RFTM. It's not a typo. It's a Rabobank file transfer manager. So, of course, you can't just like exfiltrate data or infiltrate data. You need to go through a system. And there are different endpoints. You have like S3 buckets, but also Linux machines. You have all kinds of like other like endpoints, but you want to control from one place how data gets from outside of Rabobank inside of Rabobank. And so that is RFTM. RFTM has an API, so you can configure RFTM. And I wrote a little controller there. So this is like an app that I installed on a cluster. And so, but basically, you see here that we're now, when we now went to customize, you saw that we went to app, like the clusters dev, and then we have some apps here. And here, you see that I'm pointing to K8s app dev RFTM. So let's see. Right, K8s apps dev, and then we go to RFTM. Here we have a deployment. But look at this. This doesn't look like a full deployment, right? This is a partial file. You only see what is specified is basically the image here. So we have an image specified, but where does this come from? So there's a customization, and then you go 2 directories up, point, base, RFTM. So you go up, base, and then we go to RFTM, and here's the full deployment. And so with Customize, it's very easy. You go from this full deployment, this is what you have, this is full deployment, but in the end, the only thing that you do for dev is you change where the image is coming from, because you have to point to the repository, or to the registry of dev, and that's what I'm doing here. I'm pointing to the dev registry. So, and it's another thing. So you've seen that I've installed an RFTM controller. So the nice thing about an enterprise is that it is a big ecosystem of technology and people that come together to create value. But they also, so what they also do is they create a value for people internally inside of the company. So, so we have a thing called RFTM, but it's not only a GUI, it also has an API. And what you can do in the enterprise, there's a bunch of APIs available, and you could build all kinds of controllers for the APIs that are already there. So this is the first controller in the Rabobank that is actually using an internal API, and I think a lot more will follow. This is an amazing process. So you can imagine if there are a bunch of APIs to do all kinds of things in your enterprise, you can not only use Kubernetes to deploy your applications, you can use Kubernetes to basically configure your entire enterprise. So working for an enterprise basically becomes like the Starship Enterprise. You can just go and sit behind your laptop and do all the things from the console. And in the end, you don't even have to necessarily communicate to all those kind of people, because you can just create your YAML objects and communicate with the enterprise like that. So I think this is good for now. I still have something to, let's see, here we go, wait a sec. Wait a sec, I need to make sure that this is gone. I actually need to check it over there. Is it almost? Yes. Oh, another one. You gotta be kidding me, man. There we go. All right. So, one thing. Show of hands. How many people are actually working for an enterprise right now? An enterprise organization? Okay. And of those hands that are up, who is not using Kubernetes at this point? Okay, you guys. Okay, so that's a very interesting thing. If you want to know how to convince your company to use Kubernetes, first of all, you have to understand, respect your organization, right? A lot of people think like, okay, the organization is stupid, they don't use Kubernetes, and that's super bad, and we're going to just fight the organization. That's not what you do. You work with the organization. They're there for a reason. You make sure you follow the process. You talk to the right people, get people together, make sure that they understand what you're doing. You also understand the perspective of management. Like I can say all kinds of things to Rabobank. I can say, yeah, we need to use Kubernetes, we need to do this or that or whatever. But in the end, management has a whole different mindset. They don't know about containers, they don't know about clusters. They want to know, does the business work? Can it continue to work? Are we in control? Are we not creating like weird risks? Like they need to ensure business continuity. And you need to make the case that the Kubernetes makes sure that you can actually have a better business continuity. And if that doesn't work, you just basically ask for forgiveness because you're just going to do it anyway, roll it out, maybe show something, and then you can beg for permission later. And if that doesn't work, you should apply somewhere else. We're hiring. Thank you.
Thank you, Sharon. That was brilliant. Thank you very much.
You're welcome.
And I was just talking with Geert from Rabobank that the very first item, respect the organization, seems kind of obvious, but it isn't. Bringing something in new requires courage, of course, but also respect for those that were not thinking it or that didn't want it. So you have to have your own way to talk it through.
Yeah.
So thank you very much.
Yeah,
Very
you're
good.
welcome.
Again
Thank
for
you.
Sherwin. Oh, I'm sorry. Where are you going? Stay here. Questions, please. Yes, we have one over there. We have one. Skip that one.
Hi, thank you for your presentation. I do have one question. I'm here, all the way over here in the back. Yeah. So I agree with the not templating your YAMLs, but what about templating your TFR files?
Templating your TFR files. For what purpose?
Just asking you.
Yeah, you could.
Well,
template.
okay, let's say I want to have one code base from Terraform from which I can inject different TFR files for different environments, for instance.
Yes, so you can do that.
Yeah, I know, but
you're allowed.
What's your thought on that?
Well, like TFR files is kind of different, right? The problem with templating YAML is you can create all kinds of problems there. There's white space that is an issue. You don't know what it looks like in the end. But TFR files is basically just a flat file. So I think that's perfectly fine to template. You don't have the same problems with just a flat file as it is with YAML.
Okay, we can talk about that then. Okay, it's fine.
Let's do that.
Sounds like a threat.
Bring it on.
Hey, thanks for your talk. There was a diagram with all of the components and then some of the things that were pinned at a certain version, like Helm and Splunk and so on. What is the update strategy for those components, if there's any?
That's a very good question. There is no update strategy as of this point.
Cool.
Yeah. No, so like, yeah, basically you can do that by hand, of course, but that's not going to work. Like you have also, like, because we're using GitOps, you can use something like Dependabot to upgrade certain types of things, but not everything can be easily upgraded. So we have to look at it per component on how to see and how specifically for day 2 operations. And that's something that, because we're in the forefront of the Kubernetes world and the cloud transformation, we are also looking at things like this and how to do that correctly.
Sherwin, we have space for 2 more questions. Are you okay to take them if there are?
Yeah, sure.
There you go.
Hi, I think you already mentioned, but I missed it probably. How are you managing secrets in the cluster? I didn't see it.
Yeah, good question.
Because
So-
you are using GitOps, so are you using kubectl or?
Yeah,
or-
well, we use kubectl in the beginning, but that's like there's a lot of overhead to kubectl because you have to cycle the keys and stuff like that. We don't want to do that. We're now using external secrets. So most secrets are in the secrets manager in AWS, but we expose those secrets via external secrets. So it's in the cluster, so the application can just consume those secrets.
Last question, Sherwin.
Yeah, is there anything you can share about what your organizational team dynamics look like to enable all those repositories and all those structures? Because if you're trying to build these for developers, if you're trying to enable developers, then are there any structures in place to have them productive, for example?
Let me rephrase that question. So you want to know basically how we expose the cluster so other people can consume it easier?
Yeah, how you enable your developers to release to Kubernetes?
Okay, yeah. So for this particular instance of the Kubernetes cluster that we have right now, everything is coming from offshore. So the developers don't necessarily interact directly with the cluster. They basically deliver the tarball, and we make sure with our CI/CD system that a Docker image is automatically created. So they don't interact with the cluster like that. However, we are looking at forming a platform team, which we're going to answer that exact question. But conversations are still ongoing.
Thank you very much, Sherwin. Please, one more for Sherwin. Okay, please do not leave the room. We are going to have, I'm going to give you one service communication. We're going to do one group photo with the whole team. And then we have our last mysterious keynote speaker.
Kelsey Hightower.
Sorry, what's that?
Oh, the mic is still on?
Okay, so we are going, after the last keynote, we are going to go, we're going to be serving drinks in the sponsor area. And around 6, maybe a little bit later, there are too many Italians in the team to make it on time. So we are going to move and have our barbecue, vegan barbecue, in the bar area. Okay? Thank you. If the whole team can join me upstairs. Yes.
Thanks.
I've been told that I can reveal the keynote speaker. Is Priyanka, CNCF director, is going to be joining us.
Ja, ik zie het volgende keer.
Thanks, guys. So, Andy, you're taking it over from me, I suppose? You are. I've been doing such a bad job that they needed the other guy from Red Hat. Hello.
Not sure if this is on or not. Oh, now it is, yeah. Priyanka's going to be our one and only virtual speaker, so we're going to see what kind of technological bugs show up while we try and make this work. So please bear with us. Do you guys want to make an announcement downstairs? Do you want to make an announcement downstairs that we're doing the keynote in about 5 minutes' time? So everybody who is here has already got the best seats, I see, so that's great. I'm just going to check. Wonderful. Everybody, thank you so, so much. It's been 2 amazing days full of amazing speakers and amazing attendees. And before we move on any further, I would like to ask everybody to give yourselves a round of applause for being such an amazing attendees for what I can only assume was a great community days. So thank you so, so much. If you haven't heard already, we are very, very lucky that Priyanka Sharma, who is the director of the Cloud Native Compute Foundation, is on the call with us right now. We have a couple of questions to ask her, and she has very graciously agreed to come and talk to us all here. So, can we connect? There we go. And Priyanka, thank you so much for joining us. Can you hear me okay? Wonderful, thank you so much. So, we already came up with a couple of questions that we thought of asking you. I hope that you might have a moment at the end, maybe for some additional questions. But before I get started with those, was there anything you'd like to say before I get started? Awesome. Thank you so, so much. So, got a couple of questions here that we came up with a little bit earlier this week. So, I wanted to ask you a little bit about the cloud native space. So, what are the biggest changes you're expecting in the cloud native space in the coming year? And where do you think you see the CNCF in a year or 2 from now?
Sure. So let me take out my crystal ball. I think the best part of the cloud native ecosystem is that it's ever evolving, right? In the past years, I mean, when we started in 2015, when I joined this ecosystem as a contributor, Kubernetes had just been donated, and we spent a while getting through the container orchestration wars, and now Kubernetes has emerged as the de facto standard. And I think this year we'll continue to see Kubernetes enjoying a Linux-like moment. I also think that with the proliferation of Kubernetes, even the work we are doing within Kubernetes for its infrastructure, the multi-cloud movement is going to gain more and more traction. I think I speak with lots of folks in the space, and they often are talking about just how they want to make cloud portability a reality. And I think strides will be made in this field through various vendors and open source contributors. So that's one thing. I think in general, I would also say, like, for end users who we spend a ton of time with, because they are the people we are all serving, it's very clear that there was the initial euphoria of like the cloud will solve all your problems, and now they're very mature, much more nuanced in their perspective, and FinOps, or cost management, is a big focus for them. CNCF has a project called Open Cost that helps in that direction, and I think more and more efforts will come from various places. Those are just 2 examples. I think cloud-based IDEs are coming like back in fashion. Before cloud native, I was doing a startup, and I remember there was this whole online editor craze going on, and then we had this ebb in that area, and now we're back to the flow, but in a much more mature way. I think that sustainability remains a key priority for the whole world, not just our context, and that will roll in green ops into FinOps. People more increasingly care about the environmental impact, about the energy impact, and all of that I expect to see happening in our ecosystem. You may or may not know, we recently hosted the Cloud Native Security Con in Seattle, and it was such an amazing event. It was so many people, close to 800 plus, and everybody there was like, oh, this feels like the original KubeCons. And I think that moment in time happened because security is front and center. Open source SBOMs will be everywhere. Cloud native security is going to play a critical role, and more people will come to this community to solve their problems, because this is where we get things done. So that's what I expect from a technology perspective. How do I see CNCF changing as an organization in the next 2 years? Well, I hope we are always changing to meet the needs of this community, which is ever growing. So just in the last year, I'll tell you, as executive director, I have the same title. My job has completely changed, which is awesome, because now we've brought in some senior leadership into the organization, because we want to put more power behind our community programs, supporting maintainers and contributors. And you will see more and more of those efforts coming out of the CNCF. You will also see a renewed and enhanced focus on trainings and certifications, because Kubernetes is having its Linux style moment, right? So that means more and more people need to be educated and upskilling. So we'll put a lot of energy there. Those are just two examples, but ask me in 2 years and I'll give you a retro.
I definitely will do. And I'm really glad that you brought up sustainability. So we had actually more than one talk just during this KCD talking about sustainability on Kubernetes. We had a couple of open source projects talking about how you can reduce your Kubernetes workloads when you don't need them. So it's really great to see that the sustainability side of cloud native computing is really coming into the focus now. Cool, thank you so much for your answer. Next question, I think I'm not going to be the only person saying, I'm going to be at KubeCon this year. KubeCon is, of course, here in Amsterdam after being cancelled in 2020. What are you most looking forward to from the event?
Oh my gosh, what are we not looking forward to? It'll, as you said, right? We were supposed to be there 3 years ago, so it's just going to be lovely to finally make that happen and be in Amsterdam again. Something I always love about KubeCons is about 50% of attendees tend to be first-timers, and that's projected to be the case this time as well. And I'm very, very happy about that, because that means we bring more and more people into the cloud-native ecosystem. I think that this year we've made actually a lot of changes. So I don't know. Have you attended? Is this going to be your first KubeCon, or how many KubeCons in are you?
That's a great question. Can you put your hand up if this is going to be your first KubeCon this year? My goodness, I think it's about 60% of the room here.
Wow. Well, awesome. We'll see you there. For those who are the 40%, right? How many of you attended co-located events or colos?
I'm gonna reckon that's about 10% of the room.
Okay, awesome. So those 10% will know what I'm talking about here, which is that the colos were out of control. We had so many, and that's awesome, right? That's because so much is happening in this ecosystem. But we heard a lot of feedback around how it was too much. It was a full week of just a lot. So we've streamlined the co-located events into a 1 day and made them shorter so that people have more bite-sized information grabbing. We've also simplified like the ticketing alongside that. But I'm eager to hear what people say of this new experience around co-located events. We're also changing up how we do some of the social stuff around the welcome booth and the party. So all of that I'm hoping to hear feedback on, because it's all brand new. So that's something. And then I would say one of the things that's close to my heart, which is work in progress right now, so you're the first to hear it as a group, is we're looking at a startup subtrack. So as cloud native matures, more and more companies have done great things here. And that includes as big as hyperscaler and as small as a 2-person startup. We want to explicitly cater to this startup crowd with a subtrack where they get educated on how to plug into the cloud native ecosystem and receive by giving. And so we're looking at the exact programming, but check out your agenda for the startup hashtag in the business value track. So those are some of my favorites to come.
Awesome, thank you so much. I think we very quickly had a question here regarding your last answer. Can I?
Yeah, my name is Bart. I was attending always the pre-conference sessions, 2 days. And now I understand I have to fly twice a year to attend a conference, and I'd rather fly once than, well, this time I'm going by bicycle, but that's another case. So why are we forced to fly twice to a CNCF event instead of having them all condensed in one location once a year or twice a year?
Just to make sure I understand the question, are you asking about why KubeCons are happening in North America and Europe?
Why are the pre-conference events now spread on other dates?
You mean things like Cloud Native Security Con?
Yes.
Okay. So Cloud Native Security Con split off because it was getting too big for it to be held in KubeCon itself, and that we couldn't accommodate more than, let's say, 200-300 people max at the KubeCon. So even if you're there, it's hard to get in. But in Seattle, we were able to hold more than double the people, and next year we expect to hold even more. But that doesn't mean that you have to travel to attend that, and KubeCon will not have security content. That's absolutely not the case. The security track actually gets more robust by splitting off this event, and there's also gosh, how much am I revealing? But there's gonna be things like security village, things like that. So by no means will the content for security or any other topic that splits off into an event, right? Such as there's one GitOpsCon coming on. That doesn't mean KubeCon will not have that content. It just means we can't hold all the people interested, so we're providing an extra avenue for it.
Great question. Thank you so much. Right, I will pop on to the next one. Looking at the time, Priyanka, I'm not quite sure how much time you have for us today, so I'm going to keep asking
I'm here
questions
for
until
you. This is early morning for me, so
wonderful.
Take the time you need.
I wanted to talk a little bit about KCDs, because obviously we're here at a KCD. And we're seeing more and more KCDs popping up all around the world. You know, we spoke a little bit earlier today or yesterday about the fact that we're trying to help up KCD Ukraine pop up, for example. In your opinion, what is the impact of these community events? And do you have any great stories from attending a KCD or something like a KubeCon that you'd like to share with us today?
Sure. I think KCDs are instrumental in making cloud native ubiquitous because they take us global in a way we really can't through any other mechanism. KubeCons, for example, the previous person who asked the question pointed out, oh, how do I get there? Or like, you know, SecurityCon, how do I get there? It's like too many times of flying. KCDs come to the person where they are, and that's what makes them so wonderful. You know, recently we were speaking with folks who organized KCD Pakistan, and it went so well, and their primary focus was growing their student community. And they showcased a lot of first-time speakers and those folks' journey in CNCF, encouraging the next generation, right? And that would be not possible, or let's say much harder to accomplish without this programming in place. We also had KCD Africa last year, where we brought forth awareness around open source technologies and how to contribute, get people more involved. So we're able to reach regions and people that would be harder otherwise. You yourself mentioned the KCD Ukraine. It's like, yeah, we gotta address that community as fast as we can. So overall, I think we're creating endless opportunities for people by having this program. We're also working, as I told you, we're always evolving. We're also working to supercharge KCDs in 2023 for 2024 so that we can support you all organizers with more and more things that you can provide as value add to your attendees. So we want the KCD ecosystem to keep growing. And actually, I would like to make a call that if y'all have ideas on how to up-level the KCDs to bring even more value to people where they live, I'm all ears because we're in the program design phase right now. So those are some examples of KCDs particularly. Even KubeCons, right? We have the DanCon scholarship through which needs-based or diversity folks, they can apply and attend. It's so sweet. Every KubeCon, I go and there's suddenly like a gaggle of students who are so sweet and so happy, and they rush up to me and they tell me, hey, are you Priyanka? And I say yes. And we're the DanCon scholars. And they tell me their stories. It invariably happens on its own. And it's the the most gratifying time for me at the conference. And they tell me just how important it is that they're there and how they plan to stick around and make a difference here, and how for them their life is changing because school, colleges, etc., they provide you curriculum. They don't provide you the level of understanding of or access that things like this can. So I'm really glad we can help.
That's awesome. What a lovely story as well. I'm going to pause here before I ask my last question to see if there's anybody in the audience who has a question for Priyanka. Yep, we've got a couple here because I feel bad standing on stage and just asking questions that I've pre-recorded too much. Yeah.
So I'm a big proponent of the CNCF, so don't get my question wrong here, but I've got a critical remark. So the portfolio of projects has blown. It's out of the sky. Do we also, I find myself trying out some projects, and I find projects that haven't changed in 4 or 5 years. I'm here for a long time, so know that. And then I look at the Git repository, and it hasn't even had a change for 2 years. Are we also shaking the tree and slimming it down? Or can we be more proactive in that way, probably, to keep it alive and to keep it vibrant?
Absolutely. Thank you so much for your comment and question. I do agree with you myself. It's so big as an ecosystem, right? 150 plus projects is not easy to parse through. Ultimately, this all rests in the hand of the Technical Oversight Committee. They lead us with their technology vision. I am a proponent of us archiving more projects that have kind of stalled for a long enough time with the right parameters in place. So I'm in agreement with you. I think the chat. I don't want to speak for the TOC here, so please understand that. But from what I observe, the challenge that they face is that they have so much inbound to process. So many projects apply to get in by either at sandbox level or incubation, that perhaps the archival process could use a bit more time and attention than it is able to get, just because their top priority is serving the community, and there's so much inbound that they have to handle.
Yeah,
but are you? Yeah.
I think we should be more critical. Is it still being used, or are there changes being added, and perhaps not immediately deprecate projects, but just put them in a holding position or whatever, right? We can always bring them alive. I mean, things can change, but we should guard, I think, the portfolio and be critical that it stays special the way it was a few years ago, and that it's not being a dumping ground for all kinds of half-dead projects.
Can I ask you a question?
Yes, sure.
Do you find that in the incubation level and graduation level projects as well, or are you seeing it mostly in sandbox?
No, incubation. I looked at Wurf 2 weeks ago, and it was the same as what it was 4 years ago. And today I heard that the sponsoring, I tried out Tinkerbell, for instance. It never worked. And today I heard that even the project, the business that sponsored it, that it has gone broke or whatever. They're not alive anymore. So I think those are valuable projects, but if it's not being grown and being, just 2 examples on the top of my head, but there are a lot more.
No, thank you for sharing, because I think sandbox is a place for all kinds of things happening, but incubation and up, I agree with you that we need a more rigorous sort of eye on what is the activity level at. I will take your feedback to the TOC and try to push them on this and get their perspective as well. But I also encourage you, you probably already know about the open TOC calls, but I think I would encourage you to attend there and share in your own words as well.
Wonderful. Thank you so much for your question. Do we have any other questions for Priyanka right now? Oh, okay, I have one last question for you, which I came up with. I hope it's not too boring. So I wanted to ask, obviously now the in-person events are becoming commonplace again. Do you have any highlights from virtual events from the last couple of years? Obviously this is a little bit biased as an organizer of an event. We tried to do our best during the 2 years to do something virtual. Do you think that hybrid events are going to be here to stay for the future? I think this also ties into the question from before a little bit, where flying is maybe not the most sustainable way to go and attend a conference. Do you think that this is going to be the future of events, or do you think we're going to go back to just purely in-person events again?
I think being able to go virtual in the pandemic was essential for our ecosystem. As you said, you organize events as well, and like the 2 years were tough, right? It's like, how do we support our ecosystems when we cannot see people? We didn't know how. And by being able to go virtual, whether it's through simple mechanisms like Zoom, Google Meet, or it is through more robust platforms that came about, it was a lifesaver. I think all of the cloud native community was able to stay together and support itself and each other because we had that option, and we did all the creative things, right? Connect the KubeCon platform, have Slack with it alongside, do the happy hours on Zoom. We all made the best of it. And the benefit we received out of it is that our reach was bigger, more people could attend, like you said. What we have also found, though, that the hankering for in-person is real. People definitely gain a lot from literally just seeing each other face-to-face, even if they don't, sit down and work on a project. I've heard product collaboration increases like almost double just by virtue of both being in the same space as somebody else. So we cannot discount the value of being able to meet each other in person. That said, I think the longest lasting impact that the virtual event time period will have for us is that the events will be more accessible online, even if they're back in person. So I do believe in hybrid events. I will say my personal opinion going through the pandemic is that the tooling was not ready for it, right? The tooling that we had was not ready for it, and it was so there were challenges. Let's just say there were challenges. So in my opinion, the hybridization of events will not continue to rely on clunky technologies. It might simplify so that somebody who is not attending in person is still able to get the content, still able to engage on places like Slack, Discord, but and then the sort of more programmed aspect happens in person. That's my perspective, but I'm one individual. When we run events in CNCF, we're a whole team. I have a really strong events team I'm proud of. So what you heard just now is the Priyanka opinion.
Yeah, wonderful. Well, thank you so much for answering our questions. Any last questions for Priyanka before we let her go? Oh, we've got two right here in the front and center. Priyanka, how much time of yours can we take up? I'm noticing the time.
Let's do these two questions and then call it. How about that?
Wonderful. Yep.
It's one question, actually.
Yep, you're on. I think.
You mentioned that you really liked the idea that the students are attending different CNCF events like KubeCon or the community days. I was wondering, like, have you thought, like, maybe like in the CNCF itself, like about getting into collaboration with the universities, or like maybe not fully fledged collaborations because people in the industry have stuff to do, but something like giving like individual lectures, or like spreading the gospel of cloud nativeness in a sense, because like at least from my experience as a student, like many universities still have like very let's just say obscure attachment to old technologies. So obviously when the students go into the industry, they'll have an opportunity to like quickly learn the new stuff, but at least in my opinion, it would be very beneficial to show them the way even before that happens. So for instance, let me give like the simplest example. Like instead of running a simple container with a database, they just install some very obscure enterprise distribution when they're dealing with their databases courses. So, what's your opinion on that? Like being able to spread the gospel among the students and the future potentially collaborators to the open source projects?
Yes, I wholeheartedly believe in that. As I said, they are the next generation or next cohort of folks who are going to make cloud native ubiquitous. So we gotta reach them. I think our events, scholarships, and the mentoring program that we run, but through Google Summer Code as well as our own LFX mentoring, are good starts. But I have definitely toyed with the idea that you're talking about of can we have a campus ambassadors program, and I think we've really only been limited by bandwidth of CNCF is a small staff. But I would love to see such a program start emerging in the community, and CNCF could hop in and support, because I agree with you that the curriculum in universities and colleges may be a little bit behind sometimes, and definitely not connected to real world examples and projects that happen. The interesting thing is, I think the connecting the dots is what's required, because you have the mentorship programs, you have the event attendance possibilities, you have the job boards. It's more getting the information there to the students. I mean, I'll tell you this. So my brother, I have a much younger brother. He's doing his master's right now in computer science, and he knows all about KubeCons because my whole family knows everything about KubeCons. And then, yeah, it's like everyone. They're like, oh, KubeCon's coming, don't disturb her. And so he knows about it, and I've encouraged him to go many times, and he's not showed up yet. And then I was talking to him the other day about how to advance his career, and I was like, open source contribution is number one. You really need to get involved. And I started sharing how at KubeCon, that's what happens. Like, visibility is given to contributors, maintainers, people tell those stories. He's like, really? You folks talk about open? I was like, you've known KubeCon for this long and you didn't realize that's what's going on? And so if that can happen to my brother, who hears about this all the time, I feel like we really need to disseminate this information. I think, as I was saying before, we need a programmatic approach. If you or folks in the community are interested in creating a minimum viable program, we would love to support it with resources and human power.
Awesome. Thank you so much. We have one more question. No? Oh, it was the same question?
All
well,
right.
in that case, Priyanka, any last thoughts from you?
It's been lovely speaking with you all. Thank you for sharing your thoughts, being candid, open. I really value this. I hope I see you around in Amsterdam at the event, and also in all our various online communities, whether it's through GitHub, whether it's through Slack. Please know you can always reach out to me or other members of the staff. We're just here to support and enable you. And it just warms my heart to see you all together over there, enjoying yourself in Amsterdam right now.
Thank you so much. Ladies and gentlemen, can you please welcome Priyanka? Wonderful. Thank you so much for your time today. I think we'll bring you off screen now. There we go. Yep, you're good to go. If you would like to touch your green screen. Would you like to come up and give the final?
I do. I
Wonderful.
can't stay away from here now.
No, you can't. You've done a fantastic job, by the way.
No, I don't.
Thank you
I didn't,
so much.
But it was too long way, so now you can go.
Yeah. Message received.
Thank you very much. Okay, so communication. Now the fun part starts. We are going to have few drinks. Is not going to be in the sponsor area. Yes, it is going to be in the sponsor area. We're going to have few drinks in the sponsor area. You guys get to spend a little bit more time there. After those few drinks, we are going to have the barbecue in the outside area, in the bar area there. And after that, can you come, Andre? You guys, everything is perfectly organized.
Later, I explained you everything like 10 seconds ago. He was like, I got it. So very quick, like short information. So right now, what we can do all together is go back to the sponsor room. Over there, we will have drinks served. You can have a final chat with the sponsor. They've helped a ton organizing this conference here by providing, like money, the funding, and everything. So thank you very much to all the sponsors that helped organize this event. It's thanks to them if we're here today. After that, there are a couple of things that are happening at this precise time. First of all, the barbecue is getting ready. So in around half an hour, we're going to have some nice vegan barbecue all together. And the workshop room is being converted into a party room. So right after the barbecue, also party will start. We will have music, DJs, and so on. And we are all we are all looking forward to like an amazing evening. So please stay with us and enjoy the rest of the evening. Thank you very much, all of you, for attending Kubernetes Community Days Amsterdam. It was an amazing experience, and we hope to see you again at KubeCon, but also in the next years. It's going to be amazing.
Thank you, Andrea. Please stay on stage. Alessandro, will you please come back? Thank you. So these two guys are very much the cornerstone of the organization. They have done hard work. They've done hard work. A lot of they have received a lot of comments from not from me, but mostly from them. I was the good guy. Yeah, and so I would like to open up now for questions for them. Do you have any questions for the people organizing this? For us? Yes, we do. This is. Oh yeah, you want a microphone?
Is it a coincidence that you're all Italian? Yes,
Can we take it? Can we take him out? Can we take him out?
We are not the only ones. It's more Italians, and just happens. Yeah. So.
Any more questions?
Have you considered pre-uploading materials before the community day, such that people who don't know absolutely anything about Kubernetes or anything can at least get to know the technology a little bit?
That's why we organize these workshops. So there was Kubernetes 101 and 201. So we strive to be an inclusive community, which also means inclusive all levels. So if you don't know Kubernetes, this is the best place to learn. We want to be the best place to learn.
That sounds good, but I would still like some more materials to read before going here.
Oh,
so
okay.
I think for the next events, that would be really cool.
Yes, you can always come to the CNCF Slack as a Netherlands channel, also KCD Amsterdam channel. We're all there, so you can also reach out. We will prepare. Maybe it's a good idea. We'll prepare some.
Thank you.
Some things.
Any more questions?
Just wanted to add one thing. Like the core group that's been organizing this conference as well is also the group behind the Cloud Native meetup here. So it's a very active meetup. We do quite some meetups throughout the year. You are free to attend. It's a very nice opportunity, for like students, but also for like more experienced people that work already in the industry to get to know companies that use Kubernetes and people that use Kubernetes as well. So you're also feel free to join this kind of meetups. It's always super interesting to have people of all kinds of experience. I think people want to have drinks, William.
I have a question. Are we going to have a 2024 Kubernetes Community Days?
If you want to help organizing it, come forward. That's it.
There you go.
That's what I'm
That's
saying.
an open call.
Yes, we are the doors are open. We are just a bunch of people that like to do these things, and yeah, please help us out. Right. It's okay. We'll give you the passport. Right, so, with this, I would really like to thank you, all the people from the venue, Make, Salomao, for the amazing video. By the way, everything was streamed, everything was recorded, so it's going to be online. So if you missed a talk because you were talking to somebody, which is great, you will find it online as well. So yes, thank you, all the audio, video guys, and everyone at the venue.
Thank you. Drink.